But I would say we can start, right?
Yes.
Okay. Can you open my screen?
Yes.
So welcome everyone to the online pitch of the Future Grids track. I think you all know me, right? I'm Margarida. I'm the program manager from BTI, the manager of the Energy Starter. And I just have a 1-minute presentation before we start the pitches. So I'm just going to go through the project timeline, the structure for today's session, and then the lineup. So the startups that will be here today and what time they will be here. So regarding the project timeline, we are in the online pitch phase. The online pitch is going to take place today and tomorrow, and the purpose is for you to select the startups that will be present at the bootcamp, which will take place in Lisbon from the 26th to the 28th of May. The structure for today, so the structure is the same. We're going to have 10-minute slots for each startup. So they pitch for 4 minutes, and then you can ask your questions, and we'll have a Q&A for 4 minutes as well. You can either ask your questions by raising your hands or writing them in the chat. And then we have a 2-minute buffer just to make sure we respect the schedules. The lineup for today, so we have 21 startups that will be here, and your job is to evaluate them. We're going to have some short breaks. We're going to have some short breaks, and the session will close at 6:20 p.m. Lisbon time. But I don't know if you want to say a few words before we start with the first startup.
No, hello everyone. I think all of you know the program quite well, and you know how it works with the online pitch. Just a kind of reminder that for the Excel file that we've sent you by email, you may evaluate it live while you're watching the pitches, or you can watch the pitches also because we'll record them and you can watch them after the session. We'll share the links with you. And yeah, we're looking forward to the pitches and your selections. So Margarida, I think we can start.
Okay, let's start. So the first startup will be Future Grid, and we're going to have Chris presenting. So João, you can let Chris in. Sorry.
He's now joining, Margarida.
Thank you.
Okay.
Hi, Chris.
Hello.
Hi. Hi, welcome to the online pitch. Thank you for being here. So we are here with EDP and we're ready to hear your pitch. I can already see your screen, so you have 4 minutes to pitch. You can go ahead.
Thank you. Okay, well, my name is Chris Law and I am from FutureGrid. FutureGrid's based in Australia, but I'm actually in Dallas, Texas. Oh, got to change the slide. Here we go. Okay, and so FutureGrid has become the solution of choice for grid edge intelligence and low voltage visibility. And we have approximately 95% of the Australian market or Australian utilities, distribution utilities in production today, and a growing base in New Zealand and in Asia. And we focus on voltage management, DER management, wildfire mitigation. We've got some advanced LV planning capabilities, and our signature activities are fault and outage detection. And this is a picture from the Heathrow transformer explosion last week, that if they were using FutureGrid software, they probably would have detected this and prevented it from happening. So why FutureGrid? Well, there's three reasons. One, we don't fail. Our pilots, 100% of our pilots have moved into a production environment, which is why we've got a growing base of customers. And the reason for that, number two, is because it's a proven solution that is able to scale into large production environments like EDPs with millions of meters. So the effort undertaken in a pilot is not wasted and can often transition to a really commercial operation. And finally, one of our key differentiators at FutureGrid is our ability to help an organization like EDP leapfrog with the latest thinking and knowledge of, say, DER integration and voltage management from Australia, because our platform represents the latest and greatest in that market. The areas that we really focus on is, I would say, reliability, whether it's proactive reliability, detecting faults before they occur by looking at signatures on assets like transformers, etc., like the issue in Heathrow, but also reactive for when you've had an outage or a storm or an event, which is increasing these days. Our ability to not only detect those outages, but help our customers restore those outages faster than they're able to do today with their existing outage management systems. And we have a lot of functionality and capability in what we call LV optimization, which is about how we balance the LV grid for increasing DER operations, which is something that's unique to our capabilities because we're really one of the main companies in the world who have done this at scale for multiple utilities in production. So the solution our solution is the FutureGrid solution for low voltage management, and it's an enterprise software application. It can be deployed securely in an on-premise environment to meet the security and privacy requirements I would suspect that EDP require for this kind of data. And we've got a wide range of out-of-the-box use cases that have been trained and modeled from our base of customers. I think it's 80 plus today. So what does a pilot look like with EDP? Well, the first bit is that we're able to stand our solution up in like 4 to 6 weeks. So it's quite rapid. And within that 4 to 6 weeks, we're able to integrate with your, say, smart meter systems, with your GIS and the relevant data we need to get the solution operational. And we can deploy it on premise or in the cloud if that's what you prefer. Most customers just prefer to deploy on premise for security purposes. And through that process, we select out of the 80 plus use cases we have, the ones that are going to be most relevant for the EDP teams to gain the most value. So, and we do all of this remotely from our teams either in the US or Australia. So just to recap, we help you leapfrog with the latest thinking and capabilities in LV management visibility. We're a proven solution in production at scale, and our pilots don't fail. Thank you.
Thank you, Chris. Thank you for your presentation. So now let's go for Q&A. We have questions for Chris.
A quick question just to understand how many clients do you have until now at the moment?
I think the current number is about 20. Yeah. So in Australia, maybe all of them, that's about 15. New Zealand's about another 10, 12 at the moment. I think we just got a new one actually. And in the US, we've got 3 or 4. So yeah, I think kind of around 20. Actually, it's a good question. What I do know is that we've got more clients than we have people in our team.
Hey, Chris. I have one question. Francisco here from EDP. What's the business model of your solution? Do you charge by a couple of smart meter data, by steps? What's the business model with FutureGrid?
Yeah, great question. It's a traditional license model designed so it can be capitalized with a utility. Essentially, the basis of the model is the number of smart meters, but it's a tiered pricing model. So as you increase in volume, the cost per meter will decrease. So as you get into the millions, obviously, it reduces in cost, and that allows us, although it may not be relevant for EDP, that allows our smallest customer size is 8,000 meters, and our largest, the latest, which we're here in the US for, is about 7 million. So the pricing model kind of works for all. So yeah, that's the only other thing that may be relevant is in production. It's not uncommon for customers to ask for a perpetual license or a perpetual style license so they can capitalize the costs. But it's really up to the utility how they prefer to do that.
Okay, so from what I understand, you work only with smart meters that are already installed by the utility. You don't have your hardware. You use your software with our hardware. But in this case,
Correct.
do you do integration with the systems that already collect the data? Can you do an integration to collect the data from that systems? And assuming yes, do you comply with cybersecurity regulations, especially here in the EU?
Yes, I think the answer is yes, we integrate to a typical pattern because it's a sort of enterprise system, as we'll integrate to the key systems, the head-end systems for usually the smart meter providers, even GIS or even the ADMS. We often get deployed in a production sense in your secure zone. In Australia here, we do control as well through our application in SCADA. So we often work in that same secure zone as those kind of core applications. But for a pilot, yes, you may not go that far. And yes, usually the way we meet and comply with those cybersecurity and privacy around the privacy requirements for the data is by adopting what we call an on-premise model that sits behind your firewall within your premise to ensure that we're kind of encapsulated by your security standards. And that's a pretty typical approach for our customers.
Thank you.
Okay. Thank you so
I
much.
also have one question. Sorry, guys. I know I think our time is ended, but just one quick question for Chris. What kind of data do you need from the smart meters, and how often do you need it to execute these algorithms?
Yeah. So I did some research on what you've got, and there's kind of three, depending on what data you've got, will depend on exactly what we can do out of the sort of 80 plus use cases. We can use your typical, what we call kilowatt hour data, or what they call interval data, that will have some use case benefit around load management. If you've got event data from the meters, which is often, sort of like that really talks to we can really do some outage management kind of activities with that. But if you've got voltage, what we might call power quality data, then we can do a lot more advanced activity. So in terms of the frequency for a pilot, it doesn't really matter because it's about sort of validating how it works. You can kind of do it retrospectively with historical data. You don't have to do it live. But depending on the use case, the faster we get it, the quicker we get an outcome, basically. But it's not uncommon for customers to get the data daily or slower to prove out the capabilities, and that still adds a lot of value for them.
Okay, thank you.
Okay, thanks a lot, Chris, for the presentation and for answering our questions. We'll get back to you with the results in the next few weeks. Okay.
Sure. Look forward to meeting you all. Thank you.
Thank you.
Bye-bye.
Thank you. Bye.
Okay. Next, we have VoltMind, and we're going to have Michael and Vincenzo joining us. So you can let them in. Hi, Michael. Hi, Vincenzo.
Hello.
Hi, welcome
Getting
to the
started.
online pitch.
Yep.
Welcome. We are here with EDP and we're ready to hear your pitch. So one of you can go ahead and share your screen and you have 4 minutes to present.
Cool. Good to go. All right. All right. Well, thank you very much, everyone, for having us here. So my name is Michael. I'm the CEO of VoltMind. I'm very excited to be here to sharing about our idea on how we can help to transform your smart meter data into precise grid capacity insights. Consumers are playing a huge part in the energy transition, and there's no doubt that our society simply needs more grid capacity to facilitate the growing demand for electricity and other needs from the consumers. However, actually delivering this more grid capacity is not an easy problem to solve because particularly when it comes to managing the low voltage grid, it's often relying on guesswork to make investment decisions. And this could lead to excessive investments and potentially even prohibiting the customers from benefiting the most from the grid. And this is really because the fundamentals have changed. We have distributed energy resources, and also we have the reverse power flow that's coming from the grid, which has never happened for the past century. This means the existing frameworks is no longer fit for purpose, as well as the incumbent technology are no longer adequate to actually handle the scale of the problems we need to address in low voltage networks. So here at VoltMind, we are trying to pioneer a new era of grid analytics using the smart meter data and AI. This is a forward-thinking approach that regardless of the stage of a smart meter deployment, we can offer insights into the grid capacity. And it's built from the ground up to help with the scale of the low voltage networks, which is not just simple a few feeders, but thousands to 100,000 of feeders. And we have a world-class research behind this technology, as well as we have already validated this with the industry here in Australia. Really, what's at the core of our technical foundation is the ability to actually analyze the low voltage grids without any models. So you no longer you need to run power flows, which relies you to maintain the engineering model and also to manage the data quality issues. Now, with our approach, you can simply get really accurate insights of your grid within minutes, and this can be scaled to all your networks. We are already rolling out our solution across Australia, helping some of the most innovative distribution networks to manage the rooftop solar, such as across the state of South Australia and Queensland. We're also quickly establishing ourselves as the definitive solution to help to deliver advanced analytics across Australia. And here, our pilot proposal for EDP will be delivering a software solution that can create the grid capacity reports of your low voltage networks using their historical smart meter data. This creates many new possibilities for your engineers because they can now carry out detailed assessments of your low voltage networks in minutes, no longer needing to model all the low voltage grids. Also, this caters for the key problems we're seeing in low voltage networks, which is both the voltage and the thermal constraints. That means for the business, you can maximize utilization of your assets, identify constraints proactively, and also help to drive the smarter investment decisions to deliver the maximum value for your business. And here are just some sample outcomes of what we have already worked with our customers, such for them to be able to see the accuracy of our engine, also getting insights of the grid, and then comparing against their existing assumptions. In terms of the pilot, this is how we envisage it would happen. There was going to be an implementation stage where we customize our software based on your needs, followed by evaluation period by your engineers. And finally, we can discuss how this could be rolled into a production system for your business. There are many competitors out there, but we believe here are some of the key things that make us stand out. We can do the grid modeling without any engineering models, and we have a strong collaboration with academia to help us stay on the edge. And finally, I'll skip over the leadership because I'm already at the 4 minutes. I know you're more than happy to discuss a partnership opportunity to help you drive a successful energy transition. Thank you.
Thank you. Great timing.
Okay, thank you.
So now let's go for Q&A. Who wants to start?
I have a question. So the pilot you are proposing is for calculating the capacity of the network, but you talked about giving insights to the low voltage grid. So what other insights can you provide in different, I guess, different use cases or pilots or so on?
Yes. Yes. So there are two things that, well, there's a few things that we do. So in addition to traditional data analysis, we're just looking at the characteristic of the data. What we can do is actually we take the smart meter data using our AI methods. We can actually derive a model of the grid. And this model of your low voltage grid will allow you to assess a few things, such as calculating what's the capacity of the grid, and also helping you to assess the voltage constraints, forecasting a voltage constraint, and the forecasting capacity constraints in the grid. So that's kind of the insights we can do. And also the thing that we're doing with Australia is helping them to determine the real-time export limits for their rooftop solar systems. This way you can give the maximum capacity to your customers and also making sure that they are operating the grid within the constraints.
Okay, thank you.
Are there more questions?
So I have one question. It's more about the business model. I saw the 60K in the pilot proposal, but can you detail a little bit more on what are you basing the 60K for us? So
Yes, so
yeah.
the 60K is more of a one-off model for the initial pilots that we do with the customers. That just factors in the engineering costs, implementation costs to actually get the software in the production-ready environment for you guys to use. Now, in terms of the business model for us, in terms of a production license, we have it will be based on the level of deployment, because what we do is we take smart meter data doing analytics on your low voltage networks. So our pricing model will be based on how many areas of the networks that you're actually applying analytics to. And of course, you can start off with the initial set, like a small set of the network, and then you eventually scale this up to, let's say, all the networks, all the areas of the networks that you are servicing. And of course, we can discuss specific modeling, like pricing models at the later stage.
Okay. And what data and what granularity of data do you need for the pilot, for the use case?
Yep. Yeah, so when we take power quality data, which includes the voltage and the power measurements, and then, well, of course, the more granular, the better. But we have worked with data from 5 minutes to up to 50 minutes, and sometimes even 30 minutes, depending on what really depends on what data you have. But of course, the more granular, the more, like say, the more accurate the model will be for you guys. Yeah.
Michael, one further question. How many days of data or which period of time do you need to get some output from your algorithm?
Yes. So probably, not probably, from 6 to 8 weeks, that's more than enough for us to build a model of your physical grid and start doing really accurate assessments of voltage constraints and thermal constraints. And of course, depending on what's a...
Yeah, I'm sorry. I was just asking, complementing my question, asking you if you can manage data holes or some period missing data.
Yes.
In some days or something like that. Okay.
Yeah, but there are multiple holes in the data that you could have, both in terms of different levels of smart meter penetration. So we don't need a full smart meter penetration. So we can work with as little as 20% smart meter penetration. Okay. And of course, if you have holes in terms of some meters fall off the communication and came back later on, and we're able to cater for those situations as well.
Thank you so much, Michael and Vincenzo, for your presentation and for answering our questions. We'll let you know the results in the next few weeks, okay?
Cool. All right. Well, thank you very much for having us here. A pleasure to meet everyone.
Thank you. Bye.
Thank you.
Bye.
Bye.
So next, we're going to have work on grids, and we're going to have Udit and Shaudia with us in the room. João, you can let them in.
Hello.
Hi, welcome to the online pitch.
Hi.
Hi. Welcome. So we are here in the room with DDP and we're ready to hear your pitch. So you can go ahead and share your screen and you have 4 minutes to pitch.
Okay, please let me know once my screen is visible and if I'm well audible.
I can see. Yeah, go ahead.
Great. Thank you so much, everyone. My name is Udit Poddar, and I'm the CEO at Workongrid. We help utilities build smart metering operations center. So we provide an integrated operations monitoring platform for smart metering and utilities. We've been in the market since 2022. We're based out of India and Australia. And we've experienced working with 15 plus utilities where we've integrated our product to 10 million plus metering points and meters, right? So when we talk about large-scale rollout of smart meters, they pose significant operational challenges for utilities. There are multiple softwares in the stack, like head-end system, MDM, CRM, WFM, and others. And all KPIs are monitored across these different softwares. There's a lot of automation issues. So for example, if something happens in head-end and a ticket needs to be created in WFM, that automation becomes problematic. The integration is complex. And every utility has their own unique requirements to actually monitor their operations across these softwares. Utilities typically build custom software solutions, which are costly, time-taking, and they don't scale with their growing needs. So to tackle this problem, what we've done is we've built industry's first and leading low-code platform to design a smart metering operations center to monitor operations for smart metering programs, right? Before we go to the solution to the product, let's look at what SMOC is. So SMOC is a central monitoring system that connects various smart metering softwares like the head-end, MDM, WFM, SCADA, consumer portal, consumer engine, to provide a 360-degree view of the smart metering operations and KPIs, right? SMOC also enables interoperability. It connects various softwares from other softwares so that we can have automation between them. For example, if a meter is not communicating in 30 days, create a ticket in workforce management system, right? So these kind of automation can be enabled via SMOC. To facilitate development of SMOC, we have designed 6 components that can be used to actually design a smart metering operations center with your own unique requirements. Number 1 is our worksheets, which supports a flexible data model. So we can drag and drop and design a data model in the underlying database that we run in. We have a pre-built integration layer to integrate with your key utility softwares to take in data. We have a rule engine that can be used to create rules for creating KPIs, metrics, and again, automating processes. We also have a visualization layer that can be used to visualize these KPIs properly and actually have your command center in front of you. We provide an automation layer. So data comes from multiple systems. It can go to then other platforms. So that entire automation can be created with our which is supported by the rule engine as well as the UI for automation. As a part of our SMOC is we've built an AI layer that can do predictive fault, that can actually identify faults in meters using the time series data that meters typically send, right? So using 6 components, we can design smart metering operations center to monitor operations at a utility level. It's a proven solution. We're running across 4 continents. We have projects with 15 plus utilities across 10 million meters. We have projects in Europe, Middle East, South Africa, and India already running. So it's a proven and scalable solution. It provides key benefits like 70% faster go live against traditional software development, 60% reduction in support and services, 80% reduction in storage of lower storage of data, and multiple use cases can be designed on the same platform. As a part of our pilot proposal to EDP, we're proposing 2 things. So set up the smart metering operations center for some identified use cases for 50 to 100,000 smart meters, and also provide the AI layer that can actually do preventive fault maintenance for smart meters. We also have use cases identified and bucketed. So these use cases can be related to meter communication and consumptions and faults and events in the meters, right? We can use these use cases to design the smart metering operations center. So the support that we need is identification of the use cases and understanding of your AMI infrastructure to actually build the pilot. And it'll be a 16-week pilot that we're proposing from scoping to commercialization. Yeah.
Thank you. Thank you very much for the presentation. So now let's go for Q&A. Who wants to start?
Hi, Edith. Thank you for presentation. My question is, what is the value, the cost of the pilot, and there are many use cases here. I won't be able to read them all, but what have you already deployed every of these use cases? What are the most common? I don't know.
So the most common use cases are typically related to communication systems from meters. For example, if a meter is not communicating for last 3 days, do this in this particular platform. If it is not communicating for 30 days, do this in this particular platform, and so on and so forth. Another common use case is consumption monitoring. For example, if a particular customer has some contracted load or can produce certain amount of energy, but they are overshooting that, then you actually create a ticket in the consumer portal, or I mean the CRM system, and so on and so forth, right? So these are most common use cases that typically occur. The bigger problem is, again, like, taking in data from multiple systems and then pushing data on the basis of those rules. So that's the most common challenges that people face, which we are solving with our platform. For a typical, let's say, 3-4 month of pilot that we are proposing, the cost can be somewhere around 100,000 euros, maybe a little lower as well, depending upon the use cases that we actually identify and the use cases that we deploy. Yeah.
Okay, thank you.
And sorry, David, go.
Sorry, and if the pilot is successful, what would be the cost? What is your business model? How would you deploy on a larger scale, or would the price be by use case, or by quantity of data, by and also a second question is, I understand that you are like a middle platform, but if we would just want for you to consume our data and to give some insights and not to give like to push work orders to the field, would you be able to do it as well?
Yes. So because we've built a modular microservice-based platform, which means we can choose what we want as a part of the pilot or the scalability, and then we can deploy that piece only, right? For example, if we don't want outbound integration, we don't have to give that. After the pilot, the pricing is typically based on number of meters or number of metering points that we are running on, right? There is no limit to the use cases that can be actually built on the platform, because that otherwise defeats the purpose of having a platform-driven approach to smart metering operation center. Having said that, of course, if we handhold, we do the implementation, then depending upon man days, we typically charge, right? So that's how we scale up. We offer the platform both on, so we are agnostic to the infrastructure. You can provide your own infrastructure. It can be deployed there. We can provide it in a SaaS model. So all of those is available. Or like, we're quite flexible in terms of what kind of deployment model you need. Yeah.
Thank
you. Good. 10 seconds. You said Europe. Can you share with us at least which part of Europe, but country, if you can go into that detail?
So we're working in a couple of actually more than two, right? Yeah, but a few with a few utilities in the eastern part of Europe with our partners right now. And also one POC going on in Central Europe. That's all that I can share at this point. But yeah, they are live projects that are running. And after extensive testing of the platform, as I mentioned, and one of the largest projects that we're live in India has approximately 2.5 million meters. So it's a quite proven solution. Has gone through rigorous testing from utilities, and it's running already as a part of our solutions to our customers. Yeah.
Thank you.
Yeah.
Thank you. So thank you so much for your presentation and for answering our questions. So we'll tell you the results in the next few weeks.
All right. Thank you so much. And thank you again for giving us the opportunity. Yeah.
You're welcome. Bye.
Thanks. Bye-bye.
So now we have Aredo Power, and we're going to have Roland presenting. Hi, Roland. Hi, Roland. Welcome to the online pitch.
Thanks a lot.
So we are here in the room with EDP and we're ready to hear your pitch. So you can go ahead and share your screen and you have 4 minutes to pitch.
Okay.
Yeah, we can see your screen. Go ahead.
Okay. Yeah, my name is Roland, and today I want to speak about error-compensated instrument transformers. Yeah, the problem is that the meter affects the accuracy of CTs and VTs. If you can see here, you have very small loads, and this is a CT, and this is a normal VT. And you can see here that the small loading of the CT will result in a positive ratio error. This phenomena is called underburdening, underloading. So the same issue is for the VT. You have a 20 VA VT and the load is very small, so you are located in the positive ratio error. Yeah, the electrical consumers are very upset with you. They tell you that you steal money, you manipulate the billing measurement, and they will bring you to court. They want to have fairness. On the other side, there are feed-in plants, and here you pay extra money for them. The complete solution with digital twins, you have here the manufacturer of CTs and VTs, and they can perform an additional measurement with the Votano 100 and the CT analyzer. These are measurement devices from Omicron Electronics. And these measurement devices are able to generate electrical circuit diagrams of the instrument transformers. They can put an CT VT model to a cloud server, and afterwards you can check the impedances of the meter in the field with cabling, of course, and you put these loads into the circuit diagram on the cloud server. Afterwards, you can calculate the right correction factors, and these correction factors can you put into the meter again. Afterwards, you have a perfect CT for your application, and you have a perfect VT for your application. And if you are changing your meter after 10 years, you can repeat this procedure, and in every case, you have a very high precision revenue metering. Proposal is for a pilot project in Portugal, we can use electricity meters from Landis & Gyr. They have already included the CT-VT correction in their setup. And we can talk to your instrument transformer manufacturer, TISA, to perform these additional measurements for the instrument transformers. And EDP, of course, maybe you can provide a medium voltage customer where we can make the right correction factors and put the measuring cabinet in the medium voltage area with very high accuracy. Yeah, the technology has a worldwide patent, is worldwide patented, but you are in Portugal are very lucky because you don't have to pay any license fees to Aredo Power. Second proposal is EDP can be part of Aredo Power. So it's a cash machine. We have only total one-time costs of 400 to 500,000 kilo euros. The annual operating cost could be estimated at 350 kilo euros. And only for the patented countries, the annual market volume is about 41 million euros. And yeah, after 17 years, we have an accumulated profit before taxes of 270 million euros. Thanks for your attention. Success together.
Thank you. Right on time. So now let's go for Q&A. Who has questions for Roland?
Yes. So from your experience, what type of clients would it make sense for us to integrate with your solution? Any kind of clients, only industrial, large clients, or how would you propose it?
Yeah, of course. The error of the instrument transformers are between 0.5 and 1% for class 0.5 instrument transformers. If you order for your customer 0.2 percent instrument transformers, the accuracy is more accurate, but of course, in any case, it makes sense because the additional measurement is about 30 euros for your instrument transformer manufacturer. And of course, it makes sense for the renewable energies because they are feeding into your system and you have to pay them. And at the moment, it is very likely that you pay too much for the power you get from the renewable feed-in plants. And of course, at the moment, you are taking more money from big electrical consumers in the medium voltage range.
Okay, thank you.
So, if I understood correctly, for us, what would make sense is to deploy only for the generation part, for the parks, photovoltaic parks, or wind parks that to correctly understand what they are delivering to the grid.
Yes, from your point of view as EDP in Portugal, it makes very much sense to take this opportunity for wind farms, big renewable feed-in plants. Yes, you're right. At the moment, you're taking more money from the consumers, and in your position, it makes sense to have this technology for the renewables. Yeah, you're right from the point of the EDP.
And do you think, of course, we are the ones that make that want the meters and make the purchase of the meters, but do you think your solution could be also for the supplier, for instance, for the I don't know which was the supplier of the meters that you
Landis
put
and Gear.
for Landis and Gear. Do you feel that your solution would also be good for them to have a better meter?
Yes, they have now integrated the right correction templates in their meter software. So we can use these meters from Landis and Gear already, and they are, in my opinion, the best ones at the moment because the other suppliers don't have this CT-VT correction factor module, not in the portfolio.
Okay, but sorry, but it was a bit technical. I don't understand everything on that side, but if I'm not wrong, Landis and Gear already has your solution or already has something that makes that takes your solution into account.
Yes, they take it. Yeah, Landis and Gear were
are they substituting you? Are they replacing you?
No, the issue was the guys at the R&D department for Landis and Gear, they were very intelligent and said, hey, we can compensate the errors. But at the moment, you only measure the CTs and the VTs in a very static. You cannot at the moment, no one generates these electrical circuit diagrams, so you cannot find the right correction factors because the impedance of the meters are varying a lot, and your cabling. So you need the electrical circuit diagram, and with this technology, you can use the error compensating module from Landis and Gear.
Okay, understood. Thank you.
Okay. Roland, thank you so much for your presentation and for answering our questions. We'll let you know the results in the next few weeks. Okay.
Okay, thanks a lot.
Thank you. Have a nice day.
Bye-bye.
Bye. Okay, so now we're going to have a short 5-minute break. Okay, let's be back in 5 minutes.
This is what I'm looking for. Be there. I'll do anything. This is what I'm looking for. Kaminati bemba de kidola mandunya Mampela suru dola sale bagi kaminati bemba de kidola mandunya La de la popela maraman La de la popela maraman Tinno masala wo Yeme de la popela maratola na tinno taba La de la popela maratola na tinno taba bimba de kidola mam dunia. La de la poupée mara mam, la de la poupée mara mam, tinong sara wo. Yemene la poupée mara tola na tinong taba. La de la poupée mara tola na tinong taba. Yemene la poupée mara tola na tinong taba. Mampela suru dola sale bagi kamila tibimba de kidola mam dunia. Mampela puru dola sale bagi kamila tibimba de kidola mam dunia. La de la poupée mara mam, la de la poupée mara mam, tinong sara wo. Yemene la poupée mara toda na tinong taba. La de la poupée mara mam, la de la poupée mara.
Okay, let's continue. So the next startup is called Eneryield, and we're going to have Johan presenting. So you can let him in. Hi, Johan. Welcome to the online pitch.
Thank you so much.
Welcome. We're here in the room with EDP, and we're ready to hear your pitch. So you can go ahead and share your screen, and you
All
have
right.
4 minutes to pitch.
Perfect.
Yeah, we can see it.
Yes, I will enlarge it also. You can see my screen,
We
and
can.
it's moving here also. All right. Yeah, thank you so much for having me. My name is Johan Rodemar. I'm co-founder and COO of Eneryield. We are a Swedish company working with AI-based analytics of power grids. And we have a software that uses voltage and current signal to predict and localize future faults. And this can then be used to prevent power outages before they happen. And we have already ongoing work with clients such as New York Power Authority, ABB, E.ON, and Vasan Sekoverko, just to mention a few. And we are then tackling the rather evident issue with power outages. And in a world with aging power grids and a growing complexity due to higher demand and the ongoing electrification of society, we see that power interruptions are happening more frequently and are a bigger issue. And the problems that follows power outages are huge, from electric utilities being unable to sell electricity to increased maintenance costs and fines from regulators and decreased life length of components. And we see that this is happening partly due to a reactive approach to operation and maintenance and a lack of data-driven insights. So this is why we have developed our solution, that is a software that is compatible with existing hardware sensor and then can be used to analyze voltage and current signal to predict a week before a fault is happening, and also to localize a fault, both future and as well as ongoing, and to understand the root cause of the same fault. This is done by leveraging explainable AI, meaning that we in an intuitive way highlight the disturbances that has contributed the most to the AI thinking it's a high likeliness of something to happen. And from this, electric utilities will be able to take proactive measures to mitigate faults. And from this, we will see fewer power failures, shorter interruption time, and reduced costs related to operation and maintenance, as well as fines. And we have a pilot proposal in mind, where we see that EDP in the first step could select 1 to 3 substation, preferably substations with adequate voltage and current sensors available, as well as locations that are a little bit more fault prone. We will then assess and make sure that this hardware setup is compatible with our software. Then we will do the deployment, and the deployment could be done in cloud-based way or on-premise. This is a little bit due to IT security aspects of things. We will then run our AI analytics and process the voltage and current signal. And from this, we will have a functional online setup that is capable of answering to the questions when, where, how, and why by doing fault forecasting, fault localization, root cause analysis, as well as leveraging explainable AI. We are very excited about this opportunity and yeah, looking forward. So let's hope we can all meet in Lisbon and discuss this further and set up a suitable pilot project. Thank you so much for listening.
Thank you. Thank you for the presentation. And it was on time. So now let's go for Q&A. Who has questions?
Hi, Johan. Thank you for the presentation.
Hello.
I would like to understand a bit more if you can go further on how you do those analyses. How can you forecast or even understand where is the fault location? That's one thing. The other is about the cost of the pilot, if you can also go further on that. And if it's manageable, 1, 2, 3, or more substations, and how would you go for a further scale up of the project?
Absolutely. Yeah, very relevant indeed. And how it is working is that first of all, we are a software company. So the idea is to leverage the existing hardware sensors that you may already have in your transformer substations. And that hardware could be digital relays or power quality meter or phase measurement unit, something capable of capturing the voltage and current signal, and it needs to be captured in waveforms also, because that's what we're feeding to the AI engine, basically. And then we look for patterns and trends in this data. And I guess the secret sauce of our solution is that we have starting to understand what features in the data that is relevant in relation to what faults that are evolving in the grid, essentially. And then we have developed a localization functionality also. And this is a little bit how well this can be done is a little bit sliding scale depending on the sensors. Because we, as a software company, we don't control the sensors. But if there are sensors on both end of the line, we can down to the meter by calculating traveling distance and doing various analysis down to the meter on the cable, understand where it is happening. If it's only measurement on one side, we can still do by doing the root cause analysis, we can see if it comes from the transformer itself or if it's from the grid. We can do downstream, upstream analysis and so on. So that's a little bit dependent on the hardware setup, but we're happy to analyze that further. And also we have, of course, partner companies that can, we can assist to install what hardware that could be needed if there is no available hardware. But of course, that's what we are looking at first. And then regarding the budget of the project, it depends, of course. But to give you a benchmark, if we're talking about one substation, and we don't need to, and we work with the existing hardware and so on. We are talking about something around 30,000 euro or so. And then, if it's more pilots, then more stations, then it adds to it. And if it would be that EDP requests assistance with some sensoring, then that's another cost coming to it.
Thank you.
Thank
you. Nothing. I understand. Thank
you. Okay.
John, can I make one quick question?
Yeah, go ahead.
What voltage levels are we talking about? So high voltage, medium voltage, and can you work on low voltage if we have sensors for that?
Yes, it's applicable to any voltage level really, but where we have deployed it is in high and medium voltage because of, yeah, there is where the sensors that are suitable are basically. But if there would be suitable sensors in low voltage, then yes, absolutely it's possible.
Okay, thank you. And I'm assuming integration with SCADA and ADMS is already, it's okay. You already
It's okay. It's okay. I
yeah.
mean, we have a very flexible approach, and we love to customize our solution to suit the client in the best way, of course.
Thank you.
Thank you.
Great. Thank you so much, Johan, for your presentation and for answering our questions. We'll let you know the results in the next few weeks. Okay.
All right. Thank you so much for having me.
Thank
All right.
you.
Bye-bye.
Okay. So now next we have Griddiagnoze, and we're going to have Magnus presenting. So you can let him in. Hi, Magnus.
Hello.
Welcome.
Thank you.
Hi. Welcome to the online pitch. We are here with DDP, and we are ready to hear your pitch. Yeah, I can see your screen, so you can go ahead and put it in presentation mode, and you have 4 minutes to pitch.
Okay, thank you. Yes, I'm representing the Griddiagnoze. I'm the CEO of the company. We are based in Ludvika, Sweden. I'm a former Hitachi ABB employment. I was selling transformer monitoring for a long time in my past, so therefore we're starting the company. And this was the problem I facing when I'm going around the world and presenting transformer monitoring is that it's a lot of data that comes from different sources. It's visual inspections that is performed on the substation. It's maintenance reports, diagnostic reports from labs. It's online monitoring data from a lot of different sensors and solutions. And we have made a cloud-based solution that overlap this problem. So what we are doing is that we're collecting data with a mobile app for visual inspection and maintenance reports. We have online monitoring by IoT connections. We connect whatever kind of sensors that is equipped already on the transformer or breaker. And we, as I said, we also collect all data from the on-site activities and diagnostics like DGA, diagnostics on breakers, all kind of diagnostics that is done on the substation or on the site. And all data goes into a cloud solution where data is organized and evaluated. And it's based on the reliable centered maintenance techniques that will be the new IEC standard also. It's based on ISO 55001. So and everything is analyzed and visualization in our web tool. And yeah, the user can use it and taking data-driven decisions regarding maintenance, repair, and investments. It was very short about that. What we cover? We cover transformer substations, distributions, substations, wind turbines, power producing plants, and we are supporting ISO 55001, and we are based on the reliable centered maintenance concept that also ISO 55001 stated to use. There is a lot of savings by going from time-based maintenance to reliable centered maintenance. It's optimizing the maintenance budget is the most direct savings. It's something between 20 and 30%. And we just doing a research study on that in Sweden, and we just confirmed the data on a utility here in Sweden. Also reduced the unplanned outages by 10 to 40%, and also reduced tied up capital in the inventory by 50 to 90%. And also, of course, increase the safety on the substation. So our contribution is that we are customer awareness and education. We're digitalizing the process that we already have. We extended the equipment life cycle, and also providing innovative solution that promote risk-based maintenance instead of routine inspection, improving cost efficiency. Yes, I see the time is out. This is the pilot proposal that we do, that we propose. 5 substation or wind farm park with 5 to 10 wind turbines, including record visual inspection, maintenance, transformer monitoring, or existing sensors on a pilot period of 6 months or something like that to evaluating the system. Yes, it was very short, and here is our comments from customers.
Okay, thank you. Thank you, Martin, for your presentation. Let's go for Q&A. So who has questions?
My question is, you can only do it with the data that we gather from the field, from the inspections, live inspection that we do, or can it be from historical data that we already have gathered?
Yes, import historical data as well, yes.
Okay.
So it's visual inspection, maintenance from the field, and also online monitoring data that from different sources, batteries, breakers, transformers, compressors we already have in the tool. So it can be whatever.
And then you have like a visualization tool as well, where we can see the predictions or the analysis that you do?
Yes.
Or okay.
So the base is this.
Okay.
You see is the probability and the consequence matrix. So there is a aggregated on the substation in this case, and then if you go down, you see on each substation on each bus bar the consequence and where your asset are in the risk matrix.
Okay, that would be for every asset of the primary substation.
Yes, correct.
Okay. And you could also integrate those that data into any system eventually, or just in your we could just see it on your systems.
Yes, of course we have communication possibilities to like SAP or other ERP system, of course.
Okay.
Yeah.
Okay. And the budget for the pilot, what would it be?
I have like 20,000 euros, something like that, for
okay.
5 substation or wind farm park. Yeah, that can be discussed, of course. But we want to have like a number of substation to be a good evaluation of the tool. If you have just one substation, you cannot compare. It's too less data.
Okay, thank you.
May I ask something?
Yes.
Yeah, go ahead.
I had microphone issues, but now it's working. Okay. For what I understood, this is a software that collects information from our reports and gives us the output is a prediction of our health index, our asset health index, and does the tool give us anything else?
Yes, it gives you, of course, it gives you a health index, and you can elaborate also with the consequence and the probability to simulate If I replace this unit or if I do maintenance, what will be the
So it
run
simulates.
with the budget? Yes.
It gives us a simulation of what we can do and what are the results of our simulation. If I propose something to do something regarding maintenance or investment, it will give us how do I say it, position information about what is the benefit of my intervention.
Yes,
I didn't saw anything in your presentation about that.
No, but it's a support to take decisions. You have a data-driven decisions. So you know where you have your risks in your network. The consequence in the risk matrix is what will be the pain if you have outages. So you elaborate with the maintenance instead of doing time-based maintenance, you're doing risk-based maintenance.
Okay.
So that is the output of the system to do risk-based maintenance instead of time-based, and that's also it's supporting ISO 55001. You have a system that is supporting you in that decision. Of course, you have a company regulation or
legal regulation.
Yes, so it's a support for you to take decisions and do investments and maintenance strategies, so on.
Do you have an example, or your presentation only has what you showed us?
Yes, I'm doing research just now for Bible, where we are studying the payback of doing risk-based maintenance. Let's see if I have some good.
I'm gonna ask if we address this offline, okay? Magnus, you can send information to me, to the team, and I'll forward it to EDP because now we ran out of time.
Yes.
Okay, so thank you for your
I can send you the
presentation.
research. I can send you the research.
Okay.
Yeah.
Great. Yeah. Send it to us.
Okay.
Yeah,
Thank you.
and we'll make sure. Yeah. Okay. Thank you for your presentation and for answering our questions. And we'll let you know the results in the next few weeks. Okay.
Okay. Thank you.
Thank you. Okay. So next we have Connor from NovoGrid. Hi, Connor.
Hi.
Welcome to the online pitch.
Thank you very much. Thanks for having me.
You're welcome. So we are here in the room with EDP and we're ready to hear your pitch. You can go ahead and share your screen and you have 4 minutes to pitch.
Yeah, I'll just get it all. Is that coming through? Super. Okay, super. Thanks. So yeah, thanks again for having me. I'm Connor Murphy, VP of Engineering over here at NovoGrid. So just an introduction to NovoGrid. We're an Irish company founded in 2014. And our mission is to efficiently deliver the world's clean energy in any way we can. We were acquired last year by a Danish company, Opora, previously SCADA International. And our philosophy in general is for our tech to be an elegant software solution that operates autonomously without an over-reliance on communications. We have, over the last 10 years, developed a number of products, mostly available in the Great British market. And our existing customers, I think yourselves included on one of our projects for EDP, SSE, Octopus, British Solar Renewables, Ministry of Defence, EDIS, ESB, and to name but a few. This is us. We are a small team of 6 electrical engineers, and our colleagues as well on the commercial side help us to actually find customers. But we have broad experience across the sector, including from the academic background for Andrew Keane, but also just in general, power system studies, planning. I myself was a planner for 3 years on ESP Networks distribution network. And we, in general, are electrical engineers developing and optimizing code, and combining those two worlds. So for GridViz and what we have in mind for this trial, it is a point-to-point estimation technique. So you might have heard of state estimation. It's that reimagined. Designed for distribution networks. It is actually operating already under the hood on one of our commercialized products, Grid Boost, but it's been reimagined here and stripped back for a DSO use case. We think there's more to be gained from it. We've successfully trialed this exact product on sections of Irish distribution networks, so we know it works at the 10 kV and the 20 kV voltage level. And our participation here is looking to target the optimized grid capacity track, but probably more so on the improved grid monitoring and control side. So what it is and how it works, it's an offline analysis that we conduct, which brings in your network model, your planning assumptions, and any field data you can give us on a particular circuit. We run our power flow analysis, the secret sauce, and then from that, we can formulate equations that are placed on the location of the measurement points. And from that, we can discern conditions of the network up to 2 to 3 to 4 kilometers away. If we've captured it in the power flow analysis, we have a good idea of what it's going to be and how those live measurements are going to impact or are impacting upstream and downstream. So we can produce live estimates of active power, reactive power, voltage, and current and loading. And if we know the rating of a particular line, we can unlock the remaining headroom. And it's all cloud-based at present, so we're up and running on AWS, and we've overlaid a map view. So this is one of our trial networks that we had in Ireland. So this is a particular feeder with 1,000 customers. Very, very long stringy network, mostly overhead. A lot of it's single phase, and we were installed on a measurement location in green there, measuring active power, reactive power, and voltage on equipment such as this seen there across A, B, and C there, overhead transformers or ground-mounted subs. And what we can do from that then is to provide our estimates for line flows and voltages elsewhere in the network, as I said. So this is measurement location in green there, and we were estimating 3 kilometers away what the flows were here, despite being spurred off that network. We had a good handle on that. So we hope to do the same thing here. I heard a timer there. Was that my time gone? Okay, right. And of course, the use cases then are untold, and we're hoping to unlock it in the next step to see what benefit it could be to the Portuguese use case. So I'll stop there and probably tackle a load of questions.
Thanks, Callum. Thanks for
that is the last slide, so it's all good.
Yeah. Okay, so we now let's go for Q&A.
Yeah.
Hi. Thank you for your presentation. I'd like to know a bit more of the measurement that you could need for the pilot project, also the costs of it, and especially for planning, what is your experience? What can you tell a bit more? Go further on your experience.
So my own experience, my own background, is it? My own
no,
career
for your solution, for the deployment of your solution.
Yeah, so it was actually for the Irish trial, it was a hybrid. We had an existing measurement set of historic measurements. So they had 100 locations around the country, and we were given those, and it was 30-minute recordings over a month. And from that we could tune our model to I suppose represent other time steps apart from those in real time. So we were probably benefited there from there being good measurements in existence there, but For this station then, an SDN 032791, they installed that for us to be able to capture, I think it was a voltage and current, and we were able to discern from that limited measurement set the algorithm when we combined it, of course, with your own planning assumptions, because we'd have to run a power flow as you might do when you're planning the network or planning for a new connection. We'd kind of mirror what kind of power flows you guys conduct in order to mirror what we'd expect the estimates to be, and then we'd, in that future scenario, hopefully validate. Okay, we had a measurement here. And you might have measurements upstream. You probably do at the HV station. That would be one way to validate that what we've done is actually accurate in other locations. So yeah, we can operate on historical data, but it's probably better to operate historical and kind of blind test to be validating these assumptions elsewhere. There was also a use case for smart meters. So across Ireland, there's an enormous amount gone into smart meters. So homes in Ireland have smart meters, and they have a very good mapping in place between homes to an MV sub, and those MV subs then wouldn't measure. We wouldn't need measurements from them. We could just take those historical logs and make an assumption about voltage, but we could probably do something there.
So your assumptions are for an estimate of the peak load that you are considering for that feeder, or an average value? What are you addressing in that sense?
On the assumptions, yeah, it's really your planning standards and what you plan the network around. And I'd be looking to kind of mirror, in particular, a backfeed or a backfeeding arrangement. So one thing this tool is great at is picking out a change in configuration. So the sensitivities to a particular voltage measurement against what it's also I suppose the P and the Q is being drawn at that location. It's able to sense that there's been a change in topology and to know to pull on a different set of equations to model those flows. So when I say assumptions, I mean everything. Like we'd be in 2 weeks trained to be planners, EDP planners, which we're well equipped to do.
Okay. Juan, thank you so much for your presentation and for answering our questions. We'll let you know the results in the next few weeks.
Super. Okay. Looking forward to it.
Thank you.
Thanks, guys.
Bye. Okay. So next we'll have Robin from Power Intelligence. Hi, Robin. Hi, Robin. Welcome to the online pitch.
Likewise.
So we are here in the room with EDP and we're ready to hear your pitch. You can go ahead and share your screen and you have 4 minutes to pitch.
Okay, here we go. Sharing my EDP from beginning.
Yeah, go ahead.
And presenter view. I'm looking for my presenter view. There we go. Okay, very good. All right. Well, hello, and my name is Robin Thompson. I'm the founder and CEO of Power Intelligence. I'm honored to have been selected as a candidate for the EDP Energy Starter Program, and I'm eager to share our exciting story with you today. During the next few minutes, we'll be taking a quick look at the problems facing our customers and the opportunities that our solutions create to increase safety and reliability at every level of the grid. A common theme among catastrophic power system failures is the occurrence of degraded, corroded, or damaged conductors and connections, which can rapidly progress from nominal functional to functional failure very quickly and with little advance warning, as is depicted in this real-world example from the Atlanta Hartsfield Airport. At Power Intelligence, we specialize in automated surveillance and thermographic analysis of critical power delivery assets like cable splices, transformers, circuit switchers, and line disconnects. Using patented and field-proven AI-enhanced infrared technology to detect and help avert catastrophic power system failures, like the recent outage at London's Heathrow Airport. This outage was eerily reminiscent of the 2017 power failure at the world's busiest airport, Atlanta's Hartsfield-Jackson International, where an 11-hour outage canceled thousands of flights and ended up costing $90 million in lost revenues to stakeholders. In the wake of that outage, Georgia Power turned to the Electric Power Research Institute and Power Intelligence to craft a solution to monitor every cable splice connection in the airport's power delivery network. Since 2019, when the Power Intel system was installed at the Atlanta airport, the system has detected numerous cases of degrading condition, which left unnoticed would eventually have led to a repeat of the 2017 outage. In each case, these detections were validated by manual inspection and remediated without incident. These are real-world examples of the power of predictive analytics at work, and the very first reason why EDP should select Power Intelligence for one or more pilot programs. Zoom forward to today, and we find Power Intelligence leading the industry once again with newly issued patents for remote monitoring of electrical substations, and by developing standalone and remote sensing platforms like the Pole Vault, which delivers global connectivity via Starlink and customizable sensor payloads. By scaling the solution down to bring it within reach of the entire utility ecosphere with lower cost sensors and solution as a service pricing. And by incorporating large language model AI as a customer-facing extension of the Power Intel analytics platform that we refer to as WhatsApp. With WhatsApp, our customers soar beyond traditional dashboards containing charts and graphs to a truly consultative analysis that incorporates knowledge from IEEE standards, engineering texts, and scholarly publications to give context to measurements and trends. This empowers utility reliability engineers and SMEs to apply their personal experience to inform the automated findings from the AI, a true force multiplier in an age of scarce engineering resources and rampant growth. This is the second reason why EDP should select Power Intelligence. And lastly, the Power Intel solution may be deployed in a variety of configurations suitable to every conceivable power system application, from underground transformer and splice vaults to distribution and transmission substations, utility-scale solar and battery storage, as well as top-tier critical infrastructure like nuclear and fossil generation. We are seeking pilot opportunities across the spectrum of EDP's applications, from underground transformer vaults to above-ground distribution and switching substations. We stand ready with a wide range of options to meet any requirement or budget and eagerly await your decision.
Thank you. Thank you for your presentation, Robin. So now let's go for Q&A. Who here has questions?
Hi, Robin. Thank you for your presentation. Can you go a bit deeper on your pilot proposal? What would you suggest and costs?
Well, as I said there, we could entertain anything from a small distribution substation with a couple of cameras and an uplink, to more elaborate installations in like transmission substations where you have multiple transformers, and the need for a larger complement of sensors, more things to monitor. So it really depends on the appetite of EDP and where they think is best to apply this technology. And certainly with the recent events at Heathrow, I think we make a great case for the experience we've had at the Atlanta airport as a great solution for critical power delivery.
And if we want to deploy your solution in one small substation, what would be the cost if we have a substation with multiple transformers or two transformers? What would be the cost, or what would be the number of devices for a bigger substation and a smaller substation?
Okay. Given that the transformer is usually the most critical and valuable asset, we could start with a small configuration of, let's say, 3 entry-level thermal imaging cameras with a communication uplink. A system like that might be $25,000. If you want to extend beyond the transformer and measure things like primary and secondary disconnects, circuit breaker bushings, etc., that could double or triple. And if you are looking at a large distribution station or, let's say, a generation switch yard, the price could exceed 100 and maybe as much as 200,000.
Okay, thank you.
Robin, and on that, do you sell the cameras or do you have a partner that sells that cameras? So my question is, does the camera needs to be anything special? Has to be a special hardware? Or do you use, like, I saw the photos, but that's like commercial cameras or not?
They are. So we have been doing this quite a while and started out using FLIR cameras. So we have native support for FLIR thermal imaging cameras. And in the last several years, we have added support for a company called Planck Vision Systems, which is actually one of the lead FLIR design engineers who left and started their own company. And in our experience, they have the best product on the market right now. Now, there is another aspect of the camera, which is whether or not a camera contains our patented algorithm, which we are working with Planck to embed that capability or a subset of those capabilities directly into the firmware in the camera. So when you see us refer to a Radix camera on our website or in our material, that is a Planck Vision camera that has been enabled with our patented firmware.
Okay.
And we will support. I mean, if you have a preference of another camera, we're happy to support, and add support for that. It just needs to make sense.
No, maybe our topic is more if they have presence in Europe, if they are capable of supplying cameras to Europe, especially Iberia.
I would venture to say the answer is yes.
Okay.
They're a US-based company. So I see no reason why they shouldn't be able to service Europe.
Okay, thank you.
Okay, so we ran out of time. Robin, thank you so much for your presentation and for answering our questions, and we'll let you know the results in the next few weeks.
Very good. Thank you.
Thank you. Have a good day.
Bye-bye.
So let's go for a short break. Okay, let's be back in 5 minutes.
Mampela suru dola sale magika mina tibimba de kidola mandunia. Mampela suru dola sale magika mina tibimba de kidola mandunia. La de la popela mala mam, la de la popela mala mam, tin long sala wo. Give me the popela mala toda na tin long taba. La de la popela mala fo, la de la popela mala fo, tifo long sala wo. Give me the popela mala toda na tin long taba. La de la popela mala toda na tin long taba. Give me the popela mala toda na tin long taba. La de la popela mala toda na tin long taba. Give me the popela mala toda na tin long taba.
Pode fazer o que quiser, até me machucar. Transborda no meu coração só amor. Desde o momento que eu te vi, não pude acreditar. Mas se eu não conseguir, vem me amar. Várias queixas de você. Por que fez isso comigo? Estamos juntos e misturados. Meu bem, quero ser seu namorado. Várias queixas de você. Por que fez isso comigo? Estamos juntos e misturados. Meu bem, quero ser seu namorado. O meu corpo balança querendo encontrar o seu amor. No swing do lodo me leva, com você eu vou. O meu corpo balança querendo encontrar o seu amor. No swing do lodo me leva, com você eu vou. Me leva, amor, meu bem querer. Me leva que assim fico louco com você. Me leva, amor, meu bem querer. Me leva que assim fico louco com você. Várias queixas de você. Por que fez isso comigo? Estamos juntos e misturados. Meu bem, quero ser seu namorado. Várias queixas de você. Por que fez isso comigo? Estamos juntos e misturados. Meu bem, quero ser seu namorado. 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 Várias queixas.
Hi everyone, we are back. Okay, so now we're gonna call Nikita from Voltquant. João, you can let Nikita in. Okay.
Yeah,
Hi
he's joining.
Nikita, welcome.
Hi, Margarita.
Hi, welcome. We are here in the room with EDP and we're ready to hear your pitch. So you can, go ahead and share your screen and you have 4 minutes to pitch.
Amazing. Sounds good. Yep. Please let me know if you can see it.
Yeah, we can.
Amazing. Amazing. Awesome. Well, yeah. Hi, everyone. My name is Nikita, and I'm the founder and CEO of Voltquant. And we build AI colleagues for the energy infrastructure sector. As you all know, project documentation is a bit of a nightmare in infrastructure projects. Every single substation, every single solar project, every single subsea line requires lots and lots of data. This data is oftentimes found in, PDFs, CSVs, OneDrive folders, and SharePoint links. And it's oftentimes humans that have to sort through all of this information to just find the right stuff. This gets a lot more complicated with the fact that oftentimes, the same workers don't stay on the actual projects over the project lifetime. So a worker who worked on a substation in 2020 might not be there when it actually comes to fruition in 2025. And in between all of the different softwares in which this data is passed through and the different users within that system, it can get quite complicated very, very quickly. The good thing is, with large language models, a lot of this sort of pain and data sharing, data management nightmare can be sort of reduced. That's because large language models are really, really good at interpreting unstructured data and kind of sequestering it into a way that makes sense. And that's how our model works. We have sort of the best energy infrastructure specific large language model. It's MIT trained, so we've trained it on a bunch of MIT open courseware material. And it, again, knows the energy sector really, really well. It then connects up to your own company environment. The company environment is a secure enterprise grade sort of location where we connect up your CRM, your email, your ERP, your OneDrive, etc. And then you can interact with the system by asking questions of the AI model, such as, I'm developing a solar project, please give me all data sets which could be useful, or by interacting with sort of the model plus your actual company data. So something along the lines of what SCADA protocol was adopted for the Portugal grid integration, or what foundation design was finalized for a transmission tower at Site 42. Current partnerships, again, we'd love to partner with large infrastructure companies. And currently, we've deployed our technology with Shell. So we've built their first AI colleague. And we're currently in deployment with both SP Energy Networks, that's Avangrid, Iberdrola, and Octopus Energy. This is a sort of, quick overview of what the platform looks like. Again, it's fully customizable. So, your own IT team can actually plug and play when it comes to integrating certain data sets and switching out the actual large language models. For example, if you don't just want to interact with our large language model, you can switch it over to ChatGPT, Anthropic, etc. Our pilot proposal is sort of a quick proof of concept delivery to kind of make sure that, sort of you see the value in this at a fairly rapid speed. So it's a 7-week pilot. But how it's worked for us currently is that usually leads to a much larger expansion. And so by the end, your organization will, sort of 9 months following, hopefully have several AI colleagues in several different departments. What we'd like from you, our ask, is that you send us some data. Send us the data for a project for which you'd like an AI colleague to represent. we'll integrate it in and rapidly deliver it, work back and forth with you to make sure that, it answers questions in an adequate way. And then, yeah, we can sort of scale it from there onwards. Thank you. 13 seconds to spare.
Exactly, right on time. Thanks, Nikita, for the presentation. So now let's go to Q&A.
Hi, Nikita. Thank you for the presentation. I have some ideas in mind, but one general question is what type of integration have you already done on the projects that you mentioned? And other two questions are more specific. Can you do something regarding documents, PDF documents, reading of PDF documents, and extracting, even if it's non-structured information, and also integration with the systems. And the other thing is, if it's like, how can I say, um, a structured Excel file where we have information on one column that relates with another column. Do you also are you able to make a connection of that information and extract some valid outputs of that?
Absolutely. Really good to meet you, David. So yeah, in terms of integrations that we've sort of currently done, so SharePoint OneDrive is a really big one for us. So that's kind of to start off with. As we've done integrations with Autodesk, we've done integrations with a platform called Asai, which is kind of for document management. It's a document management system that sort of consultants use to send sort of data to infrastructure companies. And then, we're currently actually working on integration with Salesforce as well. So that will, hopefully be delivered quite soon. In terms of data that the system can currently read. So yes, absolutely. PDFs, it's amazing at. And actually, because basically we're doing quite a bit of work with engineering teams, sort of what it's specifically good at is pinpointing the exact page from which certain information was taken, because that's kind of half of the pain points, I guess, is, okay, fine. You've said that it comes from this document, but this document's, 250 pages. Where exactly, which line exactly is it taken from? So it can do that really well. CSVs, yes, we can do. We've got sort of, I guess an SQL agent, which we plug in, and then it can analyze CSVs as well. And also images, actually. So we can interpret images, and we can extract information from there. We have a lot of hand drawings of systems. And so, we have a module which essentially reads those.
Okay. Thank you.
So that's sorry, David. Go.
No, I was thinking, what about DWG files like blueprints, let's say, of primary substation and stuff? Is it able to
we can
grasp
definitely
the information?
So currently what we've done is we've extracted kind of design principles, but those are usually in PDFs. And so we are actually building an integration. It's more with Autodesk in terms of actually sort of designing like a sort of layout for one of them. But PVG files, not currently, but we can definitely build that in.
Thank you. Go ahead, Paulo.
Thank you. Yes, my question is that's regarding the input, the information input, and what about the output? You just give plain text. You can make a CSV back, or what do you give back to the user?
Yes. So we kind of have currently two functionalities. Well, two types of functionalities. One is a pure kind of chat interface. So it can, kind of return a CSV, or it can return text. And then we have like a workflow kind of sort of functionality, which is kind of what I mentioned earlier on, which is sort of the system extracts data from sort of PDFs, like design rules and principles, and then it populates like a CAD template of sorts with like the user input, and then sort of it generates like a report or a CAD file at the end of it. So it's kind of either chat or it's a workflow.
Thank you.
Margarida, can I do one very quick? And
Yeah,
is your model more, how can I say in English? Is integrated to talk more in an engineering language? Because the problem that we have with other solutions that you know that are in the market is they talk non-engineering, and engineering terms differ a lot. That's my question. And then if you can go to prices, but maybe you can send it to Margarida, and Margarida then can share with us. My first question, maybe it's more important.
Yeah, absolutely. So that's exactly what our model is really good at. It's good at picking up engineering terminology, and it's also good at modulating the type of responses that you get back. So, for example, if you ask, a more generic question, this is actually not necessarily model, it's more how our model is set up. But if you ask a more generic question, like give me an overview of everything that's happened on the substation, you kind of want a larger response. Whereas if you, and it will give you that larger response. Whereas if you ask something specific, like what's the CRA lining made out of on this subsea line, it will realize that, okay, you're actually referring to a specific value, specific set of values from a specific document. You do not want a fluffy answer. You just want a couple of lines, that sort of describe the history and where that data's come from. And so it can modulate the response. But exactly that, it understands the context of the engineering setup really, really well. And then in terms of your second thing, it's per seat pricing. So the initial pilot fee is, it depends on the amount of users and sort of the use case. But then it's a per seat sort of standard licensing. And I can sort of send out more information to Margaret afterwards.
Please do. Thank you.
Okay. Great. Thank you, Nikita, for your presentation and for answering our questions. We'll let you know the results in the next few weeks.
Brilliant. Awesome. Thank you, everyone. Really good to meet you.
Thank you. Bye.
Thank you.
Okay. Next, we're going to have Koen and Nan from MindTrace. So you can let them in. Hi, welcome to the online pitch.
Hello, everyone. Nice to meet you.
Nice to meet you as well. So we are here in the room with EDP, and we're ready to hear your pitch. You can go ahead and share your screen, and you have 4 minutes to pitch.
Let me get there. Can you see it?
Yeah, we can see it. We can.
All right.
We can see the notes and not yeah, exactly. Now it's great.
Okay, 4 minutes. So should we get started?
Yes, go ahead.
Okay, so we're a MindTrace. Thank you very much for your invitation. 4 minutes. We have a BrainSense platform that does an incredible job. Let me walk you through. First of all, just a little background on the company. We've been at this since 2017. We operated in UK, Europe, and North America. We deliver incredibly high accurate inspection results. We focus on distribution and transmission power line segment. We have inspected over 100,000 miles of power lines, so we're a proven asset. Our benchmark results is roughly 95% reduction in data to actionable insights and 98% accuracy and 100% consistency. The problem is We know that everybody is flying copters and digitizing the data. The biggest challenge that we see in distribution and transmission sector is people trying to manage through massive amounts of data, which is LiDAR based, and trying to make sense out of it. Some of the customers that we have served, just a small example is PG&E, Idaho Power, some of our partner UFD in Europe, IBM. We work with very large companies. Bottom line, the challenge is unstructured data. How do they manage through that? There are a lot of small software companies, but it only provides less than 50% accuracy and often requires manual intervention to increase the accuracy up to where it needs to be. Oftentimes, it gets outsourced to outside country. What we bring to the party is we deliver accuracy on proximity alerts and asset condition, specifically focusing on power line sector. So the speed and accuracy is our value proposition. Some of these, essentially, what we can do is once the LiDAR data is collected, we will classify, vectorize, and analyze in 10 days as opposed to typical 5 to 7 months. The typical pilot proposal that I think should be considered is vegetation encroachment with weather impact analysis. Because of the fast cycle time, we will provide predictive AI defects, analyzing the power lines, proximity to various vegetations, and incorporate that based on the weather conditions. The value is, excuse me, my mouse. So I'm not sure exactly where we fit in your value proposition on the power grid stability. The reality is that more power will be needed. Power must be transmitted either through transmission or distribution lines. And we analyze that sector extremely well. Again, 100,000 miles that we have inspected serving major utility companies, primarily in North America. So we're a proven asset. We propose that we take about 300 miles of LiDAR data. We could turn the data over in less than 2 weeks and provide full analytics that could be evaluated by the end customers. Just a small recap. We have proven use cases with strong customer reference, and all the data that gets collected by an enterprise, we provide very unique enterprise-specific digital twin, such that as these assets are having to get analyzed over time, there is a baseline from a digital transformation perspective, people to be able to analyze. I hope I did not go over 4 minutes. It was really fast, so that's all I got.
Thanks. Thank you for the presentation. Now let's go to the Q&A. Who wants to start?
I can go. Hello. My question is more, what type of data do you ingest in terms of hardware? Well, so do you take drone data, but can you also ingest, like, for example, satellite data or even cameras that our workers can take to the field? And the other question is more, what is the business model of MindTrace? And in small ballpark, 100, let's say 100 kilometers pilot would be the cost of experimenting your solution.
Okay, so data. Unstructured LiDAR data, we don't care whether it comes from satellite, helicopters, or drones. We will manage through all of them. We understand their strengths and weaknesses. We will normalize them, but essentially unstructured, calibrated LiDAR data. On the RGB side, which is more on the camera, since the copters are flying, doing them both, capturing LiDAR as well as RGB, we will consume RGB data as well to do very unique defect detection as well. Hopefully that gave you some idea on your first question. Second question, for 100 miles, it's really nothing. Most of the time is just understanding the data that you're giving to us, right? Because not all LiDAR or RGBs are normalized the way it should be. In terms of the cost, probably about $1,000. I don't see this to be a major revenue-making operation. We just want to show you and cover our costs to see how accurate and how impressive it could be. Again, I emphasize we've been vetted through quite a few energy companies managing through their requirements.
Thank you. And then I have one more question. You have on one of your slides S-Smart Systems, one company called S-Smart Systems. I'm curious just because we already worked with them. We have an ongoing, not ongoing, but it's in the conclusion phase of the pilot. Just wanted to know what type of relation do you have with S-Smart Systems? So is your software in their product, or can you elaborate a little bit more?
So eSmart Systems is a very, as you know, very strong European player. They provide their LiDAR data to us for us to do the analytics for them, and we give it back.
Okay.
Okay.
Thank
It
you.
is very likely that eSmart System, I know Douglas very well as Eric, who is their CEO. I think they're trying to create their own AI infrastructure. But what we do for them is give us the LiDAR data, we'll give you the output. That's been the relationship.
Okay, thank you.
Okay, great. So thank you for the presentation and for answering our questions, and we'll let you know the results in the next few weeks.
Great. Thank you very much.
Thank you. Bye.
Thank you. Bye. So next we have Michael from FlyNex. You can let him in. Hi, Michael.
Hello, hi.
Hi, Michael. Welcome to the online pitch. So we are here with DDT, and we are ready to hear your pitch. So you can go ahead, share your screen, and you have 4 minutes to pitch.
Okay, great. So you can see my screen?
Yeah, we can. Yeah. Go ahead.
Okay, perfect. Let's go. Hi there. Welcome, everyone. I'm Michael, one of the founders of FlyNex, and today I'm excited to introduce you to our innovative digital. It's designed to make it as easy as possible to inspect your assets and to always have the latest insights into the current condition of your assets. So, as we all know, critical infrastructure is the backbone of our society, but nowadays we live in a vulnerable environment where on the one hand, we need to build more infrastructure, especially in energy and in a more decentralized environment. While on the other hand, the existing parts of our grids underlie more and more requirements. And at the same time, there's a big lack of educated and skilled labor. So yeah, we need to be more efficient in digital. And we want to help to secure the resilience of our critical infrastructure through automated inspections. Yeah, just imagine a world when infrastructure inspections are seamless, efficient, and highly accurate. And our end-to-end digital solution makes this vision a reality. So we are FlyNex. We are a passionate team of 35 people with the mission to transform the way how inspections on critical infrastructure is currently done. And therefore, we've developed a complete systematic data-driven inspection process in form of an software as a solution or software as a service platform with 3 pillars. First pillar, it's a web-based and visualized asset and data management platform for pretty easy navigation. And to ensure also the compliance. Second pillar is the automated data acquisition, especially with drones or any other sensors. But for drones, we have dedicated flight patterns depending on your assets. So really everybody easily can gather data and it's completely compliant with the approval process. And the third and most important pillar, and this is a pretty cool thing, is the data analysis. And the data is automatically assigned to the right asset for the analysis. So for example, like rust, bird nests, yes, and all the anomalies you want to detect on. So no complex data handling anymore. And it saves a lot of time. And out of that, you get comprehensive and detailed reports that you can also import into your existing ERP. So yeah, one of the advantages, you're always in full control of your data and no detail is overseen. Yes, to ensure the success of our solution, we do offer a customized validation and a pilot project at a specific area at your infrastructure. This includes identifying the specific needs, selecting a pilot area, and setting up the data analysis automation. So our pilot-based validation approach is proven to improve the efficiency and reduce costs, and making it a valuable precondition for scaling the operations. And together, your team and us, we will operate the automated inspection and the data generation with drones. And based on the generated data, we will set up the whole data analysis automation. The aim is also to enable your team to conduct the drone missions independently and to run the whole process through our software solution and platform. So why us? Why FlyNex is the right partner for you? So we are the right partner for your infrastructure inspection needs because our solution is easy to implement. It's proven effective in different environments of different TSOs and DSOs. And this is the most important thing, it's scalable for various assets. So it's also adaptable for other use cases such as surveying, volume measurement, 3D models, and construction progress documentation. Yes, thanks for your time. And now I'm really excited and thrilled to get your questions. So just in time.
Thanks, Michael. Yeah, right on time. Thank you for that. So now let's go for Q&A. Who wants to start?
Michael, if I understood right, you do the flights and the inspection of the images and stuff. On the flights, what kind of images do you take? It's just RGB and LiDAR or just thermal? Do you use what kind of drones do you use? And that's it.
So basically, we provide the software platform and we enable you to do the flights on your own. And that's why we automated the whole flights. And the sensor, to be honest, it doesn't matter. So it can be RGB. Depending on the sensor, we also create the flight pattern because the bigger the sensor, the more far away you can fly it, the more efficient you are. It also can be thermal images. The most important thing is the data to contain a geo position that we can assign the data to the right asset. Yeah, that's it. And maybe one thing more, and that's why also the pilot project, depending on the maturity of your drone operations. For example, if they are not in-house currently, we also can provide that for sure also as a service. Then we also use our own platform. For example, if you don't use drones in a scalable way currently. Yeah.
Okay, thank you.
Hi, Michael. I have one question. In terms of outputs, what kind of things can you provide to us? Files, a platform? What are the things that come from you crunching the images?
So we provide a platform, and once the single images are imported, different things can be created, like orthophotos, like 3D models, LIS, LRZ files, geotiffs, whatever you want. That's the main thing. Also, elevation models, as a geotiff, for example, it's there. And if there are any specific data formats like maybe DWG, DXF, whatever you want, we also can create it. That's part of the pilot then as well, to customize the solution. Does it answer the question?
Yes. Do you also do GIS correction if needed?
Yeah.
Like we tell you the pole is there, but it's not there. It's like 100,
Yes.
100 meters to the left or to the right.
Yeah, this is part of our job. So 300 meters is not the size we're actually dealing with, but at least there's always some meters difference.
Yeah.
Yeah, absolutely.
Okay. And yeah, I have one more if no one is in the queue. It's more about your pitch deck. You have here one use case with 50 Hertz. Can you elaborate a little bit more what you did with them?
So 50 Hertz is a client currently. It's not in the pilot phase anymore. So they use the platform. They imported their grid, and conduct the data generation automatically. And they, for example, use it for the power pole inspection as well as for the construction of new power lines. For the measurement, how many area was damaged or not, how is does the compensation to the landowner look like?
Okay, thank you.
Welcome.
Pedro, I'm not sure if you're talking. No. I know. Okay. We ran out of time. So thank you, Michael, for the presentation and for answering our questions. We'll let you know the results in the next few weeks. Okay.
Thank you for your time. Looking forward to see you again. Bye.
Bye. Okay. So next, we have Carlos from Invicsa Airtech. Hi, Carlos. Welcome.
Hi, good afternoon.
Hi, welcome to the online pitch.
Thank you
So
very
we
much.
are here with DDP, and we're ready to hear your pitch. You can go ahead and share your screen, and you have 4 minutes to pitch.
Great, thank you. So I share my screen now. Please let me know when it's visible for you.
Yes, we can see.
I can make full screen. Is it good?
Yeah. Yeah, go ahead.
Okay, thank you. So what we are seeing today in current aerial inspections is that we use a lot of time with our drone pilots to go and be displaced to the place that we have to fly, and then to make the operation, to ask for all the permissions, which is usually up to 25 days, and we are always restricted to the pilot availability. And additional point, we have no real time of the data processing. What we propose is a fully automatic recurrent mission system in which we have a delocalized pilot. It means that we don't have to displace the pilot to the facility, but it's the drone which will be living in a box and will be making all the operation automatically, and a system which is communicated through a cloud computing system, which is at the same time merging the pilot orders, the UAV orders reception and sending the data, and also an AI image recognition system and alert report generation. This is our remote surveillance station proposal. So the application is to have remote pilots, remote pilot control center in only one place or limited places where we have the UAS control and image processing from these headquarters. We can do with this aerial operations with automatic takeoff, automatic landing, and battery recharge. This is a video of an example of our first pilot that we are already performing. So as you see, the drone box is opening, the drone then is taking off, making the whole operation. It's sending in real time via our 5G connectivity system, which is Invicsa Airtech made. So it's our own system. It's not passing via any other server. When the mission is finished, it will land again and on the box where it can recharge again. This has been our first application in which we have obtained already permissions in Spain to make this operation with no one, absolutely no one around. So we have our headquarters, the drone station is based in here, and we have to displace absolutely no one to make this operation. This is the first operation which is allowed in Spain to be flights like this, because there are other operations which require some people present, even for emergency response, but we don't. We have obtained the permissions in order to make this. The roadmap of Invicsa Airtech for this year is to keep installing this type of autonomous systems all over Europe. Our business model and the scope market is in this area. So we made already a proof of concept in 2024 for airport inspections. We have our first operating client, as said, in Spain for surveillance, and we bring today our POC opportunity for energy generation and distribution. We put absolutely everything. So we put the pilot, we put the insurance, we put the autonomous inspection, and we put the AI cloud computing. So it's absolutely end-to-end solution in which you have only to receive the data you want when you want it. This is the founding team. So we have 4 aerospace engineers at the top of the founders. We have now 9 people in the team. We are being accelerated by European Space Agency. We have different awards in Spain, being named the top 101 by ENISA. The projects and proof of concept that we bring to you are to apply this operation for on or offshore wind turbines, in which we could be able to make these operations. And the second proposal that we bring is to make this nested drone solution for thermal plants. I just wanted to share this with you. I'm really looking forward to hearing from your questions and your proposals.
Great timing. Thank you, Carlos, for the presentation. Let's go for Q&A.
Yes, hi, Carlos. David from Aredo. Thank you for your presentation. I just wanted to understand, would you be able to install, or would you want to install something on the premises of one of our primary substations? We are a DSO, distribution system operator, so we don't have wind parks or neither offshore, neither onshore. But would you be interested in installing one of your nested drones on a primary substation of ours, and from there to go through a line or something?
Absolutely. Actually, the example I showed in the pilots we have for today are for airports and for surveillance. Regarding energy, we are being applying both for generation and to distribution, which we could install this kind of drones of automatic inspection in different places. So it's absolutely, we apport the technology. It's up to be discussing with you together, which is the best solution that you think we could apport more value.
Okay. And about the drones, what is the length of your BVLOS drones?
There are 2 things. One thing is that the distance between the pilot and the drone is not limited. So this is absolutely infinitive. We can control a drone which is flying in Australia. And then the distance between the box and the drone is up to 7 kilometers in radius in this hardware. But I wanted to share also, and to be clear, we are absolutely hardware agnostic. So we don't really care which is the drone we use. If you want a different drone, we can equip our system software system on it. Actually, we use DJI drones because they are, from my point of view, the best in market today. But they are also very difficult for us to be using our software inside. They are quite close. They're a little bit like Apple for drones, and we have worked a lot in order to be able to have our software compatible with them.
Okay. And would you be interested in just because you have your solution is not only the drone inspection but also the analysis of the images, right?
Yes. For airports, for example, we have made a hardware to identify objects on the runway, which are objects that they have to make the inspection every time. We have reached to identify objects and locate them up to 1 centimeter. So it's a little coin. And we are working on different softwares to identify hot points. But it's also another value that we have at Invicsa Airtech. We have a software specialist in AI, which are working on different solutions.
Okay, but if you would want just the images that you get, would you be interested in that as well?
Yeah, sure.
For instance, if we have our own platform for the inspection of the images.
Yes, no problem. We are used to that actually, because we sell the end-to-end solution because we are able to do all the single parts, every single part, but we are also open to work in individual steps of the chain of value.
Okay, and I don't know, and about the price, I don't recall the price that you said, or if you said any price for these, how would it be?
The standard price that we have for each drone in a box, it's we make a monthly invoice, which is between 3.5 and 5K per month. And we put everything. So we put the pilot, we put the permissions, we put just everything.
Okay. And do you find it easy to have those permissions in Portugal, for instance?
We find it quite hard to obtain them in Spain the first time.
Okay.
Now I find it easier to obtain it in Spain, and I'm very confident that we'll be able to export the system because we are in this migration to the common European regulation.
Yes.
So we have this point in our favor, and our scope, as said, is to once we have made it in Spain, I think Spain is one of the most difficult places to make it. Actually, the regulation is a little bit more severe than the rest, and I'm very confident that we'll be able to make it in other countries in Europe. And this for us is very good opportunity to try.
Even from Portugal, because we really are a complicated country in terms of bureaucracy.
I know you are. Actually, we have been working already on proposals for the airports in Portugal. It's also managed by Vinci, which is a French company, but again, the regulation is quite severe. But it's one of the added value we have. We are 4 aerospace engineers in the team. We have all the competencies to make all these aerospace safety management and so on.
Okay, thank you.
Thanks to you.
And sorry, everyone, for having just me the questions, but that's it.
Okay, if you have further questions, do not hesitate to come back to me. You have my contact.
Yes.
Okay, great. Yeah, we passed the time. So, Carlos, thank you for the presentation and for answering our questions. And we'll let you know the results in the next few weeks.
Sure. Thank you very much. Have a nice day.
Thank
Bye.
you. Bye. Okay, so let's go for a short break, 5-minute break. Okay, we'll be back in 5. Yeah.
aqueça, me vira de ponta cabeça, me faz de gato e sapato e me deixa de quatro no ato, me enche de amor, de amor. Lança menina, lança todo esse perfume, disparatina, não dá pra ficar imune. Ó teu amor que tem cheiro de coisa maluca. Fica meu bem, me descola um carinho. Eu sou neném, só sossego com beijinho. E vê se me dá o prazer de ter prazer comigo. Me aqueça, me vira de ponta cabeça, me faz de gato e sapato, ah, me deixa de quatro no ato, me enche de amor, de amor. Lança, lança perfumes, lança, lança perfumes, lança, lança, lança perfumes, lança Lança menina, lança todo esse perfume, disparatina, não dá pra ficar imune. Teu amor que tem cheiro de coisa maluca. Vem cá meu bem, me descola um carinho. Eu sou neném, só sossego com beijinho. Vê se me dá o prazer de ter prazer comigo. Me aqueça, me vira de ponta cabeça, me faz de gato e sapato, me deixa de quatro no ato, me enche de amor, de amor. Lança, lança perfumes, lança perfumes, lança perfumes,
Hello. Okay. So next, we're gonna have Carlos from Fuvex presenting. João, you can let him in. Hi, Carlos.
Hi, how are you?
Hi, good, thank you. Welcome to the online pitch. We are here in the room with EDP, and we're ready to hear your pitch. So you can go ahead, share your screen, and you have 4 minutes to pitch.
Perfect. So let me, 1 second that I share the screen. Do you see my screen?
Yeah, we can.
Yeah, perfect. Okay, so for the second time today, I pitch for you because I am in the Deep Tech Alliance also. So I have a little bit of runway already. So our goal in Fuvex is to automate the aerial data capture with long-range drones. As you know, right now, the main aerial tool to inspect the power lines continue to be crew helicopters. which are expensive, have emission and personal risk. Probably you are aware of the last accident in Spain with 3 dead, unfortunately. And what we want is that this stops to happen as soon as possible. And that's why we are replacing crew helicopters with long-range drones, lowering cost, no personal risk, and completely sustainable. And to do so, our magic, let's say, is to increase the range of the drones 20 times compared with conventional drones that you already know. So to do so, we have developed the ecosystem, the technological ecosystem for different type of aircraft, fixed wing, multicopter. We have already developed it. As you can see, these aircraft are operated by us. In terms of authorizations, we achieve after 4 years at the first authorization of its kind to go up to 10 kilometers, 20 times the conventional drone, the range of a drone. So, and with that, we are already working with distribution, providing visual, thermal, and LiDAR data for Naturgy, for UFD Naturgy, and a group both in Spain. And we are already starting to work with evacuation power lines of renewable parks. So with that, we started in 2022 after achieving the first authorization of its kind. As I mentioned before, we inspected the first 1,000 kilometers of power lines in Spain. In 2023, over 5,000, and last year 9,000. And as far as we know, we are the biggest project inspecting fully the infrastructure with LiDAR, visual, and thermal data. We have achieved the biggest commercial drone contract in Spain for Naturgy to inspect all the power lines until 2026 and potentially 2028. We're founded in 2013, 7 patents, and we have grown from 6 to 55 team members in practically 2 years. So what are, in a nutshell, what are our competitive advantages? We provide the full inspection, and that's our main advantage, that we provide LiDAR, visual, and thermal data. We develop our own technology. For example, what you see there is that we are working to integrate LiDAR and visual data so you can use the data is synchronized. We can speak about that later. And we have developed our own ecosystem, and we are already industrially deployed. This is not a startup. We are in a scaling up process. So what we would like to do is far simple. Is we want to inspect your power lines in Spain, and no surprise there. And for distribution, evacuation power lines from your renewable section, and also emergency inspections after storms and floods. That we are already doing that, and you are already invited to come with us to fly and see our aircraft on our system whenever you want to, and that's pretty much it from our side.
Thank you, Carmen. We still have some extra time. Great, thank you. So now let's go for Q&A. Who wants to?
Hi, Carlos. Can you thank you for your presentation. Can you tell me how long are the flights that you can do? And
how long? Can you repeat the question, David? Sorry.
You mentioned, I don't know if it's 10 kilometers that you can have the
we have
the flights. Yeah,
we have authorization to 10 kilometers radius. In that radius, we can do, depending on the type of payload, but up to 20 kilometers. It depends on the area. Other areas we use our own multicopter because, for example, in Galicia, it's a quite mountainous area and it's complex and it has some regulatory issues. But in central Spain, we are mostly using the fixed wing aircraft, and that can go up to 20 kilometers with LiDAR sensor. We are working in new technologies and bigger aircraft, but that's coming in 2026.
Okay, and you usually can do the inspections for. Okay, you have those kinds of. You usually use your fixed wing drones or for the
usually we use
10 to 20
a mix because right now it's not as easy as just one solution for everything. So we mostly use the two on the upper right side, the yellow and the other one, that's ours. But we also use commercial drones, DJI. They are very useful in urban environments. So at the end of the day, what we do is the client give us the area, and what we do is to inspect the area, and we look for the solution. We have inspected Madrid, it's a very complex area in terms of airport, everything, and we look for solutions. The drone is just a tool, and that's what we see. We develop our drones not because we want to, it's because we don't see anything that fits in the market for the future. DJI is very good. These Chinese drones, they are very good, but it's not scalable. In the next 2 years, they are not going to inspect 100 kilometers per day. Our goal is to inspect 100 kilometers per day with our drones. So that's to completely replace helicopters. So right now, we are around 30 to 50 kilometers per day, depending on the day and depending on the area. And the goal in the next couple of years is 100 to 200 kilometers per day inspected per drone.
So the bet is on doing more in a fewer time basis. More
basically,
kilometers.
We have 7 teams deployed right now, and with the same, last year we inspected 9,000 kilometers. We are already doubling the last year, and the goal is in the next 3 years to grow a lot in kilometers. Our ambitious goal is to in 2020, in 3 years, to inspect over 100 kilometers of 100,000 kilometers of infrastructure. And we don't want to grow with teams. We want to grow with technology, and that's what we are doing.
No hay nada aquí, puedes llamar, pero ahora ya parece que está empezando a recuperar.
No, I don't know if Pedro was talking with us, but the thing is, sorry, and I got lost. Sorry.
Don't worry.
I have one question. Thank you. I have one question, Carlos. You talked about the use case of emergency inspections after storms and flood. My question is more. I understand that you can go quickly, but then you have to have the authorization from the nautical entity. In Portugal, it's the military entity that gives that, and normally it takes like 5 days, because that's a use case that is important for EDP, but it's blocked because if it takes 5 days, our teams by foot already went there. Our goal was to get there 30 minutes. I think in Spain you also had like mass storm now passed through, so we need that quickly, 30 minutes maximum, 1 hour maximum. How do you tackle that for that use case?
So that's precise, and right now you need a segregated airspace. In Spain it's 10 days, and we have already spoken with the military and Aire, which are the authorities. So yeah, you are completely right. In Spain it's even worse. So the way we are tackling that is, so far they are not expecting a massive deployment. They are expecting something more the area, but we are working on authorization, and there are ways to get around that area. I need more time to explain, but we can do it. And in 6 months, we preparing that, we can do it with a new authorization. We can enter in details in another meeting.
Share with Margarida, or yes, and then in a future meeting we can. But if you have more information about that specific use case, please share with Margarida to share with us.
But in this case would be to operate without a segregated airspace, so to fly very low, very close to the ground, let's say, and then you don't need a segregated airspace, and then you can operate with a NOTAM. NOTAM can be deployed with emergencies in less than 24 hours.
Okay, yeah, because you keep it below a ceiling, and then the military authority doesn't.
No, it's that civilian authority doesn't require you to segregate airspace.
Yeah.
So the military doesn't under, and we can discuss it. We have a team of regulatory aspects, and there is some ways. The difficulty is then how to fly low, because it's not easy when you are flying in areas that are usually complex. You have to remain in the radio line of sight of the aircraft, but it can be done. It can be done.
Okay, thank you.
Sure.
We ran out of time so far. If there's any additional information you want to share, feel free to share it with my team, and we'll make sure IDP receives it. Okay. So thank you for the presentation and for answering the questions. And we'll let you know the results in the next few weeks.
Perfect. Thank you. Bye.
Thank you. Bye. Okay. So next we're gonna have Mitja from the company Beagle. Hi, welcome.
Hello, hi, nice to meet you, all of you.
So welcome to the online pitch, and we're here with EDP, and we're ready to hear your pitch. So you can go ahead, share your screen, and you have 4 minutes to pitch.
All right, just a second. And here's the screen. And then I can start right away.
Yeah, go ahead.
Okay, hello everyone. Nice to meet you. My name is Mitja. I'm one of the co-founders of Beagle Systems, and we have built a data collection machine for faster, cheaper, and better geospatial data. So what you can see here on the screen is the current coverage. So we are mostly operating in Germany right now, inspecting already thousands of kilometers per month of DSOs and TSOs infrastructure, gathering optical images of very large assets, also doing methane sensing. And we really enable this through automated long-range drones. We are the largest operator of BBLOS drones in Germany currently, and I'm happy to introduce you a little bit deeper into how this all works. So our system is really designed as a service. We make it very accessible to get to this high level of detailed data. So usually we just get the requirements from the customer, we get the infrastructure information, where is the asset that you want to inspect. We just deposit or we deploy a drone, ideally from a charging station, and inspect the asset on a regular basis, autonomously carry out these inspections, and then analyze the data provided to you for a digital and safe way of inspection of your assets. This works for high voltage overhead lines, but also for pipelines. That's well proven in many customer cases already. And yeah, we can really move away from manual inspections. We have a very high level of detail. I'm sure you're all familiar with drone data, but this makes it accessible for thousands of kilometers of grid. And with that, you might be able to replace helicopter inspections, reduce the amount of climbing inspections on towers, and yeah, really get to an overall safer and more sustainable way of operation in your grid operations. Looking at the pilot that we would like to propose, I mean, in general, as I showed you in the beginning, we are already operating a lot in Germany and the neighboring countries. For us, it will be great to expand our customer base who also go to new markets, go to Portugal, and we are thinking of a demonstration of a section of your grid at your disposal. You can pick a part that would be interesting for you of substations or potentially also gas network. And we would carry out all the preparations necessary to do such a project, pre-mission planning, risk assessment. We would get the permissions, do the BBLOS flight operation, and also do the post-processing of the data. And in the end, you would receive a report on the data. We can, of course, elaborate on integrations into existing systems like GIS systems or workforce management systems that you're already using. And I think, yeah, it will be a very interesting opportunity. We've proven a lot of well-working business cases with German operators, and we would be very happy to also introduce this technology to you. Thank you for your attention. Oh, wow, I'm 8 seconds sharp.
Thank you, Mita. Right on time. So now let's go for Q&A.
Of course.
Thank you, Mitja. How would you address the complexities of the regulation in the Portuguese or Spanish airfield. And if, for example, in this pilot proposal that you have for 30 to 50 kilometers of overhead lines, how would you address it in terms of the deployment of your drone and eventually some timelines for the respect of the regulations and also for the rest of the deployment?
Yeah, absolutely. So in general, our operational permits are under the EASA regulations, so they are valid throughout the entire European Union. We know that there are national specialities or requirements, and we have experience with the neighboring countries. So we have experience in operating outside of Germany in another European state. We are aware of the fact that there might be national like special requirements, but I think we are well prepared for that, and of course would address any issues. But in general, as long as it's under the JAROS SORA, the EASA regulations, we see definitely a possibility for that. And then for the 30 to 50 kilometers of demonstration, that would be a single day operation. Typically, should be 1 or 2 flights, depending on the flight pattern, on the inspection pattern for the infrastructure that we're looking at. So yeah, depending on the location that you're picking, we will make a proposal for a takeoff site. We could meet there all together. We could show you the systems. We can make a demonstration there. You can supervise the flight, get a first-hand experience there, and afterwards we'll share the data with you. I can't see
Sorry.
you right.
Yes.
Oh,
Yeah. Having that said, do your drones fly 30 kilometers? Is that the length from 30 to 50?
No.
One drone can do that flight, or what is the maximum length of the flight
Yeah,
that
the
they can do
typical
on one?
range, including a safety buffer, is about 110 kilometers on our drones. And then
On one flight?
Yeah, on one flight.
Okay.
And then it depends, of course, on the inspection pattern. So if we just need to fly like along the line, then we can do more. If you would require us to take photos from different angles of an individual mast, then we would loiter around masts and take photos from various angles. So that would be depending on your requirements, your expectation, would be something that we would discuss in preparation of such a project. What would you like to see? Maybe you have some experiences already, and then we can adapt to that. So 30 to 50 kilometers is, let's say, on the more conservative side of things, but with a high level of detail. If you would be interested in covering a large area, we could totally do that. So we have a productivity of about 700 kilometers per day with these systems that we've proven in our day-to-day operations per drone.
Okay. And would it make sense to have a drone based on a primary substation to take off from that substation and go through a line and eventually come back, or like have a base and go back and forth?
Yeah, absolutely. Sorry, my camera seems to be stuck. Yeah. Absolutely. Yeah, we do that in Germany quite sometimes. So whenever there's like a suitable infrastructure as a takeoff and landing site that's is also capable of hosting, for example, a drone hangar, we do have this system. So after a pilot project, next thing, if we go to a regular operation, that would be the ideal situation to have a fenced off area where it's like secure for the drone and there's like no uninvolved people walking around. So that would be ideal. We could do that, but we could also take care of scouting a location. That would be also definitely possible.
Okay. I don't know. Any more questions? Thank you.
So thank you
All
so
right.
much, Mitchell, for your presentation and for answering the questions. We'll let you know the results in the next few weeks. Okay.
Thanks a lot.
Thank you. Bye.
Bye-bye. See you. Bye.
Okay. Next, we're gonna have 3 people from Airpelago. So we're gonna have Tobias, Samir, and Sergio. Anyways. Hello, welcome.
Yeah.
Welcome to the online pitch. So we are here in the room with EDP and we're ready to hear your pitch. So one of you can start sharing your screen and you have 4 minutes to pitch.
Okay. Shall we introduce ourselves first, or this is?
Sorry?
Shall we introduce ourselves first, or we just start with the pitch straight away?
You only have 4 minutes, so maybe it's better to start with the pitch right away. Yeah.
Okay, no worries.
Yeah.
So yes, I'm sharing my screen here.
Yeah, I can see it.
Good. So slideshow.
Okay, go ahead.
So I'm here today to present you Airpelago. So at Airpelago, we do efficient power line inspections with autonomous drones, and we implemented a service and the software solution for this. So Airpelago started as a software company in 2018 in Sweden. So now 6 years later, we are the largest drone service provider in Europe for overhead electrical lines inspection. A game changer for us is that we have a certificate called an LUC, which allows us to fly beyond vision line of sight and autonomously in all ESA countries, meaning European Union plus Norway plus Switzerland. So our focus is in data collection. We can collect on the grid of our clients any type of data, meaning LiDAR, optical images, or infrared images. So a few numbers about Airpelago and our progress. So we have now plus 50 clients all over ESA countries. We inspected so far 70,000 kilometers of overhead lines. We have 6 offices. One of them is in Lisbon, where actually Sergio is based. We have 80 plus certified drone pilots all over Europe, ready to go on the field and inspect. And we have 100% client retention. So all our clients of the last year decided to stay with us this year. So this is an example of how detailed the pictures we take can be. So you can see pretty much every detail on the grid. So yeah, so what challenges do we tackle? So it's easy to fly a drone to inspect one tower or to take a picture on a specific insulator. But when it comes to deploying drones at scale, there are actually a few challenges that our clients faced. So first being the cost efficiency. So the second one is standardization, because the data should be collected in a consistent manner. So it's understandable and can be used for several tasks like training AI, for instance. And then regulations and the safety of the flight. So how we tackle these challenges? We implemented automation. Our flights are fully automated. So the drone flies by itself around the assets and collects the pictures. Flight permits, this is what I mentioned before. We have an LUC, which allows us to self-authorize our flights, BVLOS, and automated to inspect the assets. And the software and our team have standardized processes that actually allow us to deploy and to scale our inspections on a country level. So Airpelago software supports every step of the inspection process. So from the risk assessment, drone planning, pilot planning, and then actually deployment on the field. And another part of the software is an online platform which allows our client to visualize all the data we collect and labelize it and extract reports. So at Airpelago, what we are? We have actually 2 ways to work with our clients. The first one is Airpelago Power as a software, so in a SaaS model. So our clients can use our solution to inspect their infrastructure by themselves and manage their data by themselves. But almost of our clients for now, they use the services. So we excel at using our own software and deliver all the data to our clients, and then they can have access to it either through custom interfaces we can implement with them, or they can just actually have access to all the data on our online platform that we can show during the questions answer phase. So this is a summary of the steps on how we implement our drone inspections. I won't go through every functionality or every category of functionalities in our software and our services, but we can display the slide during the questions and you can ask me specific questions. So what we need to know here is that Airpelago software and services delivers full scope services of inspection, and the solution and flight patterns are adaptable to client use cases. It's highly configurable to match your inspection policies and the points of interest of your grid that you would like to tackle. Thank you very much. And this is us.
Great. Thank you for the presentation, Samir. So now let's go for Q&A.
Hello, a very easy question. What kind of drones do you use? Multicopters, wind fixed drones, and what kind of energy do they use? Thank you.
Actually, we use DJI drones. So it's DJI is the biggest manufacturer of drone in the world. So they are available everywhere in Europe and pretty much almost everywhere in the world. So it's a multi-copter drones. They run on electrical batteries. So for all most of our inspections, our drones, they weigh less than 2 kilos. So it's a small drone with sophisticated cameras. In some cases, we can use also a DJI drone, which is a bit bigger, but it's still a few kilos. So it's not large hardware, which is difficult to manage in terms of logistics. And using actually off-the-shelf drones of the bigger manufacturer gives our clients all over the world the possibility to purchase their own drones and then use our software in plug-and-play mode. So this is actually a strength that we have because all our competitors who manufacture their own drones, at some point they face actually some logistical challenges into ensuring enough production and the logistics and the support all over the world.
And how do you deal with the autonomy limitations of those drones?
So today the drones we use, they can fly plus minus half an hour, let's say up to 40 minutes, sometimes a bit less depending on the wind, depending on the payload and conditions. So how it goes in, how it works actually on the field. The pilot arrives with the car. He has actually in the car a big charger, batteries. So he actually selects on the app that we implemented on the remote control of the drone what he wants to inspect. So the drone goes and inspects, as far as he can with the battery. Then he comes back also in autonomous flight. Then actually the pilot takes the drone, moves to the next inspection point, and he starts the drone again. So the pilot actually is always monitoring the flight of the drone, which is a regulatory requirement. And his job also is to manage the batteries and to make sure that he has actually enough batteries to inspect the scope that we need to inspect.
And how is it compared in terms of money or in terms of money? Yeah. How does it compare with the BVLOS per se with autonomous or drones that can fly more than 30 or 40 kilometers and make those inspections?
Yeah, I don't have a generic answer to this question because it depends on the specific drone and actually what are the conditions for this drone. So today, actually, first of all, I doubt that there are any electrical powered drones that can fly that far and with that type of autonomy. At least multicopters, fixed wing maybe, but multicopters, it sounds difficult to me looking at the evolution of batteries. First of all, this kind of drones, there will be a lot of barriers by deploying them. The logistics are not the same as for us. These bigger drones that can fly that far, they need actually more logistics to land. They are not available off the shelf. The cost to purchase them will be much higher than the drones we use. The drones we use, they cost more or less 6,000 euros per drone. So it's quite easy to deploy and it can be done all over the world. And the last barrier actually is flight permissions. So we have this LUC, and to get actually the LUC, which allows us to fly beyond vision line of sight everywhere in Europe and in autonomous mode, we need to have an audit of all our procedures. So the hardware used is also actually part of the checks that the aviation authorities do. So when you have actually a drone of the biggest manufacturer in the world, it already has all licenses and has all the verifications to have this kind of flight permissions. So it's much easier to get the kind of permissions that we have with this type of drones.
Okay, thank you. But you know that there are players in the market that have those requirements for their drones and those certifications for flights over more than 30 kilometers, right?
Yeah.
But as you mentioned, fixed wing and not copter.
Yeah, but fixed wing actually cannot do the job that we are doing. It's impossible because what we do is actually the drone goes and it goes around every tower. It stops, it take a picture of the insulator, then it can go down, it can take a picture of every single corrosion and all of this automatically, just following waypoints. So the fixed wing can have actually some kind can have some business cases where it's actually really better than using multicopters. For instance, I know that some competitors use it for LiDAR collection. For LiDAR collection, it can be more efficient because we collect LiDAR still with multicopter. It's also efficient, but fixed wing is a serious competition, technically speaking, for that. Also, if you want to do overview flight post-storm, you want to see actually where the towers are broken or you have huge tree, that's actually fixed wing can also do it, but we can also do it. And I think we're competitive in terms of prices. But to perform proper asset management, like the kind of requirement that EDP have actually, which we saw several times, this kind of drones can't be used. And that's why at EDP, I mean, multicopters fly around the towers and not fixed wing too. But I don't know in some other cases.
Okay, thank you.
Welcome.
It's also
Okay,
important to, sorry, but it's also important to manifest that more than the technology involved, it's regulatory. So even if you have larger autonomy, and I can say that for granted, you have a lot of manufacturers in Europe, none of them have a LUC like us for this kind of inspections. Most of them, what they only get is corridors, but corridors cannot be deployed for this kind of inspection specifically, just to mention that.
Okay.
Okay. So thank you all. We ran out of time, so we need to finish the session. Thank you for your presentation and for answering our questions, and we'll let you know the results in the next few weeks. Okay.
Yeah. Thank you for your time, and if any questions, just email us, and we're happy to answer. Thanks.
Great. Thank you.
Bye-bye.
Thank you. Bye.
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 Okay. Next, we have Osvaldo from Laki Power. Hi, welcome.
Hi, thank you.
Welcome to the online pitch. We are here with EDP, and we're ready to hear your pitch. So you can go ahead and share your screen, and you have 4 minutes to pitch.
Okay, thank you. I'll share my screen here. So over the last few years, we've been deploying advanced monitoring systems that combine high-resolution cameras and precision weather sensors to monitor icing and wildfire risks. At the core of these systems is our patented power harvesting technology used to power energy-intensive hardware directly from high-voltage lines. We've already partnered with renowned grid operators around the world in recent years, placing our stationary monitoring devices in critical locations on their grids. And now we're applying that experience to a new frontier.
Sorry, I'm sorry to interrupt, but what we are seeing is the Word document.
Okay. Okay. So let me.
You can just put that on full screen. It should look better already. Oh, all right.
Okay, yeah,
there we
yeah.
go.
Okay, now we can see the document.
Never
Yeah, I
mind.
wasn't sure. Thank you.
So we've already partnered with renowned grid operators around the world in recent years, placing our stationary monitoring devices in critical locations on their grids, and now we're applying that experience to new frontier drone-based power line inspections. So power line inspections often take place in remote locations across challenging terrain, which means sending teams into the field is both costly and logistically complex. And the level of detail involves looking for hairline cracks, loose fittings, and early-stage corrosion on insulators and connectors. To inspect these components properly, you need drones that can get close, hover precisely, and navigate complex tower geometries. That's why quadcopter drones are the tool of choice for detailed tower inspections. And because of their precision, stability, and hovering capability, they're able to capture the imagery needed for making critical decisions that can prevent outages. But even with all their advantages, battery life remains the biggest limitation of quadcopter drones. In the field, you're typically getting 40 minutes of flight time under ideal conditions, enough time to inspect 2 to 3 towers, and then the ground crew will manually change batteries before continuing inspection. Enter the LKX drone, a network of charging stations placed directly on power lines at 13-kilometer intervals, effectively removing the range barrier for quadcopters and opening the door to fully autonomous power line inspections, eliminating the need for ground crews and manual battery swaps. Any LKX drone mission involves the following three-step sequence. A drone is set off on a predefined inspection mission. 2, the drone collects imagery of relevant towers or other potential targets. And 3, before the battery runs low, it returns to the nearest charging station where it docks, recharges, and uploads data. In a recent PwC report, they analyzed the cost of drone-based inspections, but even in PwC's autonomous scenario, they still assumed there would be personnel on the ground managing battery changes. Our analysis shows that by enabling true autonomy, the LKX drone system can reduce inspection costs by 60% compared to the current mode of operation. Even more importantly, once the charging network is installed, the marginal cost of additional inspections essentially drops to zero. To validate the system, we're proposing a 3-month pilot project in collaboration with EDP. The pilot would follow a clear structure: deployment of multiple charging stations on a selected transmission line, execution of autonomous inspection missions, including docking, recharging, and data upload, delivery of high-resolution image data to the utilities maintenance team, and finally, performance evaluation on inspection quality and cost savings. At the end of our pilot, we aim to prove the advantages of the LKX system from an operational and economical perspective, proving the worth of a system that could be scaled up to span the entire grid and revolutionize grid inspections. So at Laki Power, we believe the future of grid maintenance is autonomous, continuous, and data-rich. Thank you, and I'd be happy to take your questions.
Thank you very much. Right on time. So let's go for Q&A.
So I have a colleague of mine here, Einar. He's the lead engineer on the project. So he can join us.
Hi, Osvaldo. Thank you for the presentation.
Thank you.
I think that it's very clear. I would just want to understand the cost of the pilot project, how many charging stations, and that's it.
Yeah, I think so we've estimated, like in the case study we created, we estimate that the commercial cost of the charging stations would be around 20,000 euros a piece. And so for the pilot, we would probably deploy, I would guess, maybe 3 charging stations in a pilot proof of concept. And then when you have the drone cost would probably be around 30,000 euros. So we could be talking about a total cost in terms of like the hardware of around 60 to 80,000 euros, in that range.
And that would be just for the acquisition of the images, right?
Yes, I mean, this is the cost of the hardware on a commercial basis. I think from your standpoint, probably the main costs on your side would be related to the installation of the charging stations, and the end result would be to, of course, provide and get the data and images into your systems. We foresee that, in the future, that we would be using services from companies like Hepta Insights or Grid Vision to actually do the analysis of the images.
Okay. And what about the quantity of images that the drone could do or could take? The amount of in terms of.
Maybe Einar can comment on it, but I think we are estimating on even if we had a 100-kilometer line, that the drone could essentially store almost all of the images related to inspecting hundreds of towers. But most likely, we've already installed here in Iceland, for instance, we have a monitoring device that already has a Starlink satellite connectivity on it. So either we can use satellite or mobile connectivity to upload images at certain points at different charging stations. So the drone doesn't necessarily have to carry all of the data and images, but it's definitely a possibility.
Okay. And what about the robustness of those charging stations and the would it be possible for the drone to be coupled to the charging station under severe weather conditions, or more wind speeds higher than some point? I don't know.
I think the drone will probably be limited by, of course, weather. In some cases, we envision that, the drone will be, of course, before starting a mission, we have to take weather into account. The charging stations themselves are extremely robust. Our monitoring solutions have been on lines in extremely demanding situations for many, many years now. So we're very confident we can build robust monitoring stations. But in the future, there is a possibility to create potentially housing for the drones, so that they can actually have a place along the grid to rest and can be deployed for missions from those places. But that's further down the road.
Mm-hmm. And do you already have the solution prepared, or in
Yes.
when would it be ready to be deployed?
We would be ready to deploy and start the pilot in the fall, in September, October. We have done a lot of testing on different components of the solution here in Iceland with the Icelandic grid operator, and so we are very far along in basically having a solution ready for testing.
Thank you.
Margarida, can I do a quick one?
Yeah.
The last one, yeah.
Hi, Osvaldo. One question. What's the voltage level that you need from the line? So do you need to put this starting station in high voltage, or can we do it in medium voltage? So do you have a limitation on the kV?
No, we can operate at any voltage level. The only requirement is that we have sufficient current. So we'll need probably in the range of 60 to 80 amps of current to operate the devices or the charging stations.
60 to 80.
60 to 80, 60 to 80.
And one final question. Does your solution have a limitation in terms of weight to the line? Because, for example, a drone with a LiDAR, it's heavy if you are putting that, or do you have some protection that doesn't put the load of the drone on the line?
The charging station itself would probably weigh around 30 to 35 kilos, and the drone having a weight around 10 to 15 max. So in terms of loading on the line, we haven't had an issue with that on the TSO side, like the higher voltage.
Okay. Thank you.
Just a final comment from my side. The charging station is a smart idea, but I think it could be optimized if you remove the charging station and you include into the drone the system to catch the energy from the magnetic field created from the current. No? So it would be better because there is much better because the line has the energy to charge the drone, and also this is a parking to park the load, the drone. So I think you have already thought about it, but I think this is the final and the best solution. And have you thought about it? This is the question.
We have thought about it. With the drawbacks we see with that are potentially having to fly with the magnetic cores, which would limit the drone's basically flight characteristics. So we think having a drone that is basically more nimble and having these stations, we can upload the data on these charging stations. We could potentially add cameras without adding a lot of weight. So the charging stations could serve also as a potential tool for surveillance, even when there's not a drone in the neighborhood. So I think we decided that it was the best route, at least to take at this point, was to have the charging stations. But it's a good question, and it's definitely something we've thought about.
Okay, great. Thank you for your presentation and for answering all our questions. We ran out of time and we've got the time.
Okay,
I'll let you know the results in the next few weeks, okay?
thank you so much. Good talking to you.
Thank you.
Bye-bye.
Bye. So next, we're gonna have Keith from Birdstop. Hi, Keith. Welcome.
Hi, folks. How's everyone?
Hi. Welcome to the online pitch. We are here with EDP and we're ready to hear your pitch. So you can share your screen and you have 4 minutes to pitch. Yeah, I can see it.
Great. Thank you for having me here today. My name is Keith Miao. I'm the CEO and founder of Birdstop. My personal background is in satellite imagery and data science. Started my career working with satellite imagery and building geospatial models at the Columbia University Earth Institute. Worked in the public sector in Washington, D.C., and later the technology sector, leading a data science team at Google before founding Birdstop. And so for me, the motivation of Birdstop is how can we provide richer, more real-time physical world intel using autonomous sensors and computer vision through the technology of drones, which to me, coming from a satellite imagery background, are like satellites that sit on the ground. Instead of an autonomous flying sensor thousands, hundreds of miles away in space, we can deploy autonomous flying sensors tens, hundreds of feet or meters from the asset and essentially create an autonomous monitoring solution. This was a pipe dream a few years ago, but now it is a reality, at least in the United States, and we would like to bring it to other parts of the world. Our company is based in California, and we do our production at our new facility in Alabama. What we do is pretty straightforward. We basically build camera systems that can fly, and we build the best computer vision optimized for those flying camera systems. We deploy them for critical infrastructure so that you can monitor those facilities without having someone in the field. We station our systems at strategic locations across power generation facilities across the grid so that, one, you can use them as pan-tilt zoom camera systems when they're docked, and when you need to monitor the facility or respond to certain locations, then the drones can get up in the air and do on-schedule patrols and on-demand response. We've partnered with the regulators in the United States for 6 years now, gaining some of the best approvals to operate autonomous aircraft in this way, using our technology in the background to monitor the airspace using optical and acoustic intelligence and deconflict that airspace to operate autonomous drones. We're in daily active use every single day now. Our customers are using Birdstop to monitor their critical infrastructure facilities, namely in power generation, as well as used in public safety. Companies choose to work with Birdstop because we are very specialized in this area of just doing the best aerial monitoring for critical infrastructure. We deploy computer vision at the edge to track anomalies that are relevant for critical infrastructure. Our systems are always on so that they can be used as a camera system in addition to being a drone, and they're built secure in the United States. We manage every aspect of the software and hardware. Our customers, for instance, Laki Power, talk about our system as being very intuitive, like CCTV cameras that can fly. Our team, our leadership, is all from a heavy aerospace engineering background using drones, balloons, satellites, etc., and our investors likewise. We hope to be able to test out this technology at an EDP, especially solar hydro facility, to demonstrate this working in that environment for 6 to 12 months. That's my time. Thank you very much.
Right on time. Thanks for the presentation. Let's go for Q&A. Once to start.
Hi, Keith. Thank you for the presentation. Are you used to make inspections also on aerial overhead lines? And if in that case, how would you address a pilot for inspecting an overhead line?
Yes, we collect data for substations as well as power lines today. We are best used when you want to survey an area more repeatedly because we essentially station a drone and allow you to operate that as frequently as possible. So we typically would station at a power generation or a substation and use that as the base of operations and operate within a few kilometers radius of that location. Of course, our vision is that you station them along the entire power grid and you, with a click of a button, can monitor to your entire power grid eventually.
Okay, but your stations can feed the drone in terms of electrical feeding.
We would need a power and connectivity source.
Okay.
And from there, you can operate it remotely and it would recharge the drone whenever it's not in flight.
Okay, but you have that capability.
Yes, yes. At all times when the drone is not flying, it's being recharged. And while it's being recharged, it can be used as a camera system that's stationed on top of a pole.
Okay. And what kind of connectivity do you need? Or do
We
you
ask for 20 Mbps up and down if that's possible.
Can you repeat, please? I'm not familiar with those names, I think.
It would be a very slow connection by modern standards. We have operated off of LTE, off of Starlink. Basically enough to stream a video.
Okay.
It would be maybe 1/5 as fast as what we would get on our phones.
Okay. That's it. Thank you.
Thank you, David.
Can you use, like, for example, fiber optic connection, or can you use like a data phone card, a SIM card?
Yes, absolutely. We are agnostic to the internet connection. So if you had a SIM card that then fed the connectivity to our perch, which is what we call this form factor here, we would be we can operate off that, and we have many units on that today.
I see the drone that you have there. It's your drone, or it's an off-the-shelf drone?
Yes, this is our drone. Previously, we used off-the-shelf drones. We've used 16 different models of drones, 4 different manufacturers. But more and more, we are putting our drone in because we designed it to meet the needs of our clients specifically, and it gives the best experience.
And it can transport LiDAR, thermal, RGB cameras. Is it flexible in terms of payload?
Yes, we use 5 types of payloads right now: LiDAR, RGB, infrared. We have a gas detection payload for methane, and we have multispectral. So those are the 5 we currently support, and we can talk specifics on the models if you're interested in that.
No, yeah. My final question is that, do you have it on already in conversations, or so my question is, if you come to Europe, what would be the steps for Birdstop to put the drone operating in Iberia, for example? Because I saw that in your pitch deck, you are focused completely focused on North America, but Europe regulations are a little bit different.
Mhm. That's a great question. So we actually started working in Europe last year in Spain. And
Okay.
so we work with INARE there, and AINA, so the aviation authorities there. And so we are becoming fairly acquainted with that. And that's one reason why we feel if we were to deploy in Europe or in Portugal, that would actually be the best for us when it comes to the first step in international.
Okay. We don't have more time. Margarida is going to say that. But if you can, please share with us the specifications of your drone, because if it's not off the shelf, we don't have it. We can find it online, mainly for the purpose of autonomy, to know autonomy. Okay, if you can share those data sheet.
Absolutely. Margarita,
Yes,
will
thank
you
you.
be able to put us in touch to share that?
Yeah, sure. Share it with anyone from my team, Manel, Rafaela. So just share it with us, and we'll send it to EDP. Okay.
Perfect. Thank you.
you.
So thanks a lot, Keith. We are gonna share with you the results in the next few weeks. Okay. Thank you for the presentation and for answering our questions.
Absolutely. Have a good one.
Bye.
Yeah.
Okay. We're almost over. Let's just do a 3-minute break, okay? And then it's the last one. Okay, see you in a bit. 3 minutes.
It's going down. 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 It's going down, 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 down. It's going It's going down, down. It's going It's going down.
Okay, let's go back. So now we have the last 5 startups. The next one is TROIA. It's called TROIA Gismanager, and we're gonna have presenting. So João, you can let him in.
He's now joining.
Okay, great. Hi, welcome.
Hello.
Welcome to the online pitch. We are here with EDP, and we're ready to hear your pitch. So you can go ahead and share your screen, and you have 4 minutes to pitch.
Okay.
We
Let
can
me
see.
know if you see.
We can. Go ahead.
Cool. Thanks. Hello, everyone. My name is Workongrid. I'm from TROIA company, and today I will be presenting GIS Manager solution for EDP. We are enterprise asset management experts in the field of energy and utilities, working with the energy distribution and transmission companies around the world, Balkan and the Middle East region. With the GIS Manager augmented reality application, we gain the X-ray-like ability to see through the ground, to simplify utility locates, assesses hidden infrastructure, and increase situation awareness with 3D BIM objects on the field. Clients are currently using various unrelated solutions that are not optimal for their processes. Let's take a look at a short video of the solution.
Does the video have sounds?
Lednik, if you can turn the volume slightly up, I think maybe it's too low now. We cannot hear it clearly. Or maybe you did not click on the option to share the volume. Can you try that again? When you share it, there should be a little box for you to tick on top saying share audio. Maybe you didn't tick that. I'm not sure.
I will play with it again then.
Okay, go ahead.
The
All right.
Gismanager mobile
There we go.
application displays us the hidden infrastructure located underground with the help of augmented reality technology on mobile devices. It enables users in the field to quickly and qualitatively view the geographical data of various types of objects, as well as technical data on the state of devices. With the help of modern application support, field teams will obtain data to support decision-making in the field for the purposes of issuing consents, carrying out maintenance work, investments, and measurements. Visualization of ALE's underground infrastructure, inspection of public infrastructure, plot boundaries and transmission line corridors, as well as insight into technical data about assets, are the main advantages of the applied approach with augmented reality technology in the Gismanager application.
Okay, let's continue. On the right side, you can see a few more screenshots from the solution. Presenting various use cases. Let's say on the left side, we have recognized topics from your needs and assessment where the GIS Manager application can step in and, let's say, support your operations to improve reliability and make an environmental impact. In general, we have recognized 2 key competitors whose focus area is primarily construction businesses, due to our key focus area is being in the energy and utility sector. The GIS Manager use cases you can see on the screen are applied to many different levels of field operations, from maintenance workers to engineers and to supervisors, which shows us broad usability options of the solution. For the pilot proposal, we are offering a one-stop shop with the GIS Manager solution pilot project usually takes 8 weeks and go through all needed phases to validate the full potential of the application and all the client's use cases. With the pilot projects, TROIA provides all the hardware equipment for the client, GIS application licenses, and also can host spatial data. EDP needs to provide mobile network connection for the mobile devices, RTK services, and spatial data for the visualization. The GIS manager approach enables quicker infrastructure locations and identification, improves also GIS data reliability and quality, streamlines better and faster maintenance processes, and boosts work efficiency, and of course, reduces costs. Thank you.
Okay, great. Thank you for the presentation. Let's go to Q&A. Who wants to start? I think you're on mute.
Maybe now or
Yeah, it's working.
okay, thank you. So my question is, with your tool, you can see in the field information coming from the GIS. Can you do all the way around? Can you include new information to GIS? Let's suppose you find something that was wrong. Can you report it and change the GIS with your tool?
Thank you. A very good question. Yes. With inside our applications, there is also functionality where users can have ability to, let's say, to make kind of annotation on the field and can update different informations, and these informations are in real time synchronized to backend systems, for example, to your enterprise asset management system, or in case if you would like to, let's say, to update any GIS data, there is also possibility to update GIS data, so there is no problem. Yeah, we need to specify with the client what data they want to manage, and we can, let's say, make in our configuration tool, and everything can happen.
Okay, I can make one or two questions. Regarding offline and online, do you have offline functionalities? And the second question, if you were you in what one or two examples of clients where you have this solution in practice?
Okay. Yeah, at the moment we are offering just the online version of the application. So users on the field needs to have mobile connection. But yeah, we have also on the roadmap and thinking about possibility to provide offline option. We're also discussing and evaluating with existing clients about that. We have, you asked also for two clients. Yeah, one client is Eles. You have seen also their use case. It's the Slovenian transmission system operator. Yeah, and the other client is Elektro Ljubljana. It's Slovenian distribution system operator, the largest one in the country. Yeah, and we are also have other clients. Yeah.
Okay, thanks.
Any more questions?
I have one. Sorry, I was talking to myself. I have one question. Is more of the business model and the prices for a typical pilot, and what's the business model? How do you charge a utility for using your solution?
Yeah. Okay, I can explain. Firstly, good question. I have written there also. I think there was price on one slide. The price for the pilot, which covers everything you have heard, is for example for 6 users, because we charge per device, is 30K. Later on, when we let's say go into production scale, we are selling licenses. Licenses are per device.
Thank you.
Okay, great. So we ran out of time. Thank you so much for the presentation and for answering our questions. And we'll let you know the results in the next few weeks, okay?
Cool. Thank you.
Okay. Thank you
Thank
very
you.
much.
Have a nice day.
Bye.
Bye.
Thank you.
Okay. So the next startup is Korall Engineering, and we're gonna hear from Bruno.
He's now joining.
Hi, Bruno.
Hi, everyone.
Okay. So we are here in the room with EDP, and we're ready to hear your pitch. You can go ahead and share your screen, and you have 4 minutes to pitch.
Are you seeing my screen right now?
Yeah, we can.
Fantastic.
Go ahead.
My name is Bruno Maffei, and I'm the CEO and co-founder of Korall Engineering. We are a Norwegian startup specializing in design and software development within the fields of spare parts and 3D printing. Our mission is to enable on-demand manufacturing through 3D printing in heavy asset industries with special focus on the energy sector. And we are already doing so by digitalizing spare parts, by generating libraries and families of spare parts, and by 3D printing them on demand. The benefits of 3D printing have become undeniable. Such a technology enables the reduction of lead times from months to days. They guarantee uptime and reduce inventories, and more than anything, also environmental footprint by allowing local manufacturing. So the question is how we can leverage this technology in order to achieve the maximum outcome. Every day, thousands of industrial parts rust away and break all the time, all over the world. One example of this is the valve handrail. This is just an example. In this particular instance, our clients replace 8,000 of them every single year due to corrosion. And when it comes to this particular spare part, there are more than 1,000 different types out there. So when our clients came to us with this problem, we did what we always do when a new spare part comes our way. We redesigned, optimized, digitalized, and 3D printed on demand. By doing so, we generated and created the most efficient, sustainable 3D printed valve handrail ever created. However, we noticed right away something important. If we were to redesign all possible types of handrails out there, it would take us months, if not years. For this reason, we created Octopus. Octopus is a digital inventory that enables saving such digitalized spare parts on the cloud and being able to 3D print them on demand whenever necessary. At the same time, it's also an automation tool, and it's able to generate families of spare parts. In the case of the handwheel, it would generate thousands of possible handwheel iterations, being able to be 3D printed on demand whenever needed. By virtue of this, for instance, our clients will be 3D printing between 1,000 to 5,000 units of products within the next year. Moreover, one important aspect to consider is the environmental footprint. By being able to 3D print locally, we're able to reduce CO2 emissions by up to 92%, given the additive properties of 3D printing rather than subtractive manufacturing. We are a Techstars company. We've been delivering 3D printing services and products to companies such as Equinor and Total Energies since 2021 and 2022, respectively. So what we are offering to our clients and partners is the integration of additive manufacturing alongside a traditional supply chain and procurement processes. We aim to do so with a step-by-step integration approach. which includes bringing that 3D printing mindset within the organization by identifying suitable spare parts that can be 3D printed on demand, by identifying more than anything use cases, business cases that can bring tangible value and measurable value to the organization right away. Eventually, bringing IT integration and hence bringing our digital inventory in order to enable the organization to 3D print on demand. This is how a pilot overview would look like, by bringing our expertise in-house, working in collaboration with the client, designing for 3D printing by finding spare parts that can be 3D printed on demand, and eventually validating the different use cases in this case. So this is what we do. We empower your supply chain with additive manufacturing and on-demand production. Thank you.
Thank you for being on time as well. So let's go for Q&A.
Yes, I have a couple of questions. So the first one is, do you only work on the software 3D printing value chain, or you also help us in the effective 3D printing in the hardware part? And the other one is if you have worked in some use cases, some applications for the electrical network for DSOs or TSOs. Thank you.
We ourselves do not own 3D printers. We help the organization to identify potential spare parts that can be 3D printed and leverage our own network, choosing the best technology for that particular application in order to manufacture the part. So we provide at the same time a software, a digital inventory, where we can store such parts. And at the same time, we help the organization identify those suitable parts that can be redesigned for on-demand manufacturing. When it comes to, we've been mostly working within, we're a Norwegian company, and our market is quite reduced. And as you can imagine, the main markets here in Norway are the oil and gas, energy, and maritime. And for this particular reason, we've been mostly focusing in these markets. We developed a small project for Eviny, which is an utility company. It was a bracket when it comes to, there was a machinery that broke, was bringing downtime and losses in the terms of millions of Norwegian kroner. So we had to 3D print on demand something very quick, a bracket, in order to make this machine work again and repristinate the operational part of this business.
Okay, great. Thank you.
Hi, Bruno. I have one question. So what's the minimum requirement in terms of data that you need? Can it go from a PDF to sometimes it happens a sheet of paper or even nothing, and we give you like a spare part for you to do a model?
Of course, a drawing and a PDF would be best, but also the spare part is enough. We've been developing some spare parts for companies such as Eni or Vår Energi, how is this called here in Norway, and we measure the part and we digitalize it. So we create the CAD design. If necessary, we optimize it, and then we're able to 3D print it on demand. So not too deep information is required for us in order to do what we do.
And are you able to print in any kind of material? Do you have limitations? So, because in power grids, you have glass, ceramic, steel, aluminum, copper. We have a lot. So, are you able to do that?
When it comes to 3D printing, at the moment, the technology allows printing almost in any material, from steel, titanium, any kind of engineering or high performance polymer materials. The only perhaps two exceptions are glass, which the technology exists, but is still not quite refined enough for it to allow a part to be printed for use or for operational use. And the other one is rubber. Rubber does necessitate of vulcanization and hence a very stringent process in order to create the part without oxygen or inside. But besides that, anything else is possible to print.
Okay. And then can you guarantee that the parts? So my question is, you print us a part, then the part needs to be CE certificated, especially for us in Portugal. Do you do that, or does your process already being pre-approved for us to say if this part was printed by Korall, it's the CE is in the CE standards? Do you understand my question?
Absolutely. Certain companies that we use that do 3D printing are already certified with a DMV for a base process 3D printing certification. But eventually it all comes to the end user. If it's a low criticality part, we can have a very quick qualification process when it comes to it. Already the standards exist. Of course, when it comes to more critical parts that may bring damage to installation or to human hazard, then it does require a more yes, a qualification in place. But we collaborate with bodies such as DMV to do also this process. We are in the process of qualifying actually some polymer materials for offshore use at the moment.
Okay, thank you.
Okay, thank you. We ran out of time, so thank you, Bruno, for your presentation and for answering the questions. And we'll let you know the results in the next 2 weeks. Okay.
Thank you, Margarita, and thank to the rest of the team. Goodbye.
Thank you. Bye. Okay. Let's do startups. We're almost there. We're gonna have Troy from EarthGrid. Hi, EarthGrid. Yes. Hi, Troy.
Hello.
Welcome to the online pitch.
Thank you so much.
We are here with EDP and we're ready to hear your pitch. So yeah, you can start. You have 4 minutes.
Okay, sounds good. I'm going to go fast. Hi, everybody. I'm going to talk about EarthGrid, a new way to put infrastructure underground faster and cheaper. Vision is new infrastructure. So a little bit about me. I'm a serial entrepreneur, 30 years developing solar farms and wind farms. I wrote a book, The Clean Power Revolution, 20 years ago. Please don't buy it because it'll put you right to sleep. But I talk about how we need to put transmission lines in to support the solar and wind. I started Tradewind Energy in the 1990s. It's now a $35 billion division of Enel Green Power. And I also started a big solar company that should hit unicorn status hopefully soon. EarthGrid's won almost every competition we've entered, so pretty grateful and humbled by that, including Startup World Cup last year. Thousands of companies applied, and we took home the $1 million prize from Pegasus Tech Ventures. Trying to improve the grid. I'll go fast because I think you all know all about this. The European grid is more underground than the US grid, so we have a lot of work to do in North America, but also in Europe. A lot of new solar and wind needs new transmission lines. Going underground can get the permitting and the licenses done faster. In the US or North America, 80% of solar and wind projects are not getting built because of lack of transmission in the weak grid. I know it's also an issue in parts of Europe. We're working with a number of utilities in North America to bury power lines to stop causing fires and other issues. According to US utility data, lines underground are 9 times more reliable and with 10 times fewer truck rolls, but historically more expensive until now, thanks to EarthGrid. So why now? I'll basically skip this. You all know, climate and weather costs are exploding and climate tech, now is the time. So here's the tech. I invented this about 8 years ago in 2016 and built the first prototype in 2017. And we've done over 1,000 tests, over 100 different rocks and geologies. So you see these plasma torches, we create electric arc in here, and then we pass air at sonic speeds very fast, and it creates plasma at 27,000 degrees Celsius, and that turns the rock into bits of sand and gravel. We can go through anything, including very hard rock, soil, wet, dry, sand, clay. We can go through anything. And our business model is on the left is our construction model, where we're basically badass is the name we came up with, boring and drilling as a simple service, or boring and digging as a simple service. So we're a badass company. So that's our construction model, where we can be like a subcontractor to a utility or an EPC. On the right, we have a boom model where we own the tunnel and we lease out space to utilities for power, water, gas, fiber, whatever. We can be up to 10 times lower cost and up to 100 times faster. In hard rock, drilling is typically 10 to 30 meters in a day. We've demonstrated up to a kilometer per day, which is crazy fast. And the cost, up to 10 times lower cost. And this is for a concrete lined 2.5 meter diameter tunnel. Obviously, the cost is less if the tunnel is smaller, like 1 meter, something like that. Global patents filed and over 1,000 trade secrets. Multiple types of infrastructure. Here's a 2.5 meter test tunnel we created a little while ago. Market's huge, you know that. Because we're non-contact, we're not using a cutting head, we can arrange our torches in any shape. So one of our mini patent claims is we can do a Roman arch shape like this, square at the bottom with an arch to put multiple utilities in the tunnel. Some of the projects we're working on and customers, including projects in Iceland that are starting later this year. In the US, EarthGrid is a regulated utility in 46 states, telecommunications utility, which gives us access to the rights of way. Wrapping up here, leadership team on the left, board on the right, some amazing people, including the former chairman of FERC is one of our advisors. Oops, that's on the next slide. And I think I'm wrapping up. That's it. We have raised $63 million of equity, including $13 million from my own family office. So I'll take some questions.
Great, thank you, Troy, for the presentation, right on time. Yeah, let's go for the questions.
Yes, thank you. So I have two questions. The first one is your solution cost effective for small holes or for small underground, couple of cables? And the other one is, can you do directional drilling with your technology? Thank you.
Yes and yes. So the smallest we can go is probably about 60 centimeters, 60, 70 centimeters in diameter. And yes, it's directional. Because we're non-contact, we're not using force or torque, we actually have a really tight turning radius. So we can take a 90-degree turn, left or right, go up or down, up 30 degrees, down up to 60 degrees. And we have a very accurate gyroscope and sensor package, so we know exactly where the robot is at any time.
Great. I have here a couple of questions.
Okay.
First of all, in complementing what my colleague said, what are the possible diameters of holes that you can make? So what's the minimum? The maximum for us is okay, the minimum. Let's stay for the minimum to know what are the possibilities of this solution. So that's my first question. And then my second question is, are you able to detect other cables when you are doing the drilling or other pipes or other things or obstacles that we cannot destroy when we are putting our cables on the ground?
Very important question. So the smallest is 60 centimeters, 0.6 meter.
Okay.
The biggest, there's no limit. We have a design, as you see here, for 8 meter, but we also have a 15 meter design, for cars or trains. So there's no maximum. And the answer to your question of line strikes, yes, we have a sensor package with 30 sensors, including ground penetrating radar and other things that can see. We'll do a survey before we start boring, and then on board the robot, we pause every few meters, let the sensors see ahead. We can see anything made of metal or plastic, but we can't see very well anything made out of really old like clay or brick. So one of our solutions is to go deeper, maybe 3 to 5 meters below the surface to get beneath most of the other infrastructure that would be there.
And what's your efficiency per day? I think you mentioned, but can you remind me?
So we're focused on between 100 meters and 1,000 meters per day, depending on the geology.
Okay. And just backtracking to my first question again, to the diameter hole, does that affect the price? So
yes, like this price is for 2.5 meter diameter. Our biggest cost to operate the machine is electricity because we use air, which is free, and electricity, which we can either draw from the grid, 480 volts or 4,160 volts, whatever. We can take anything, or we can use a generator. And so if we're able to use lower cost electricity, our cost goes down. It's about half of our cost. But anyway, this cost here, $500,000 per kilometer, is for a 2.5 meter diameter tunnel. If it's a 0.6 meter, obviously the cost is going to be far less than that.
Okay. And in terms of certifications, do you need any? I know in North America, probably you need a couple of certifications, but is the equipment need any special authorization for you to do that in North America? And do you have it?
Yes, and we got our first project approved, actually our first two projects approved in California, which is probably the most difficult state in the United States to get approvals. So we had to go through full environmental review, and the project was approved by the California Public Utility Commission. And so that helps us a lot in other states, and we think that will also help us in Europe. But there aren't any like specific approvals because this is brand new technology that's never really been done before.
Okay, thank you.
I have one very quick last one, Margarita, if it's okay. So you manufacture the machine and then you own the machine. You do both, right?
Correct.
Okay, thank you.
Yeah, we'd love to find ways to support EDP on projects, eliminate geology risk, and save time and save money.
Thank you, Troy. Thank you for the presentation and for answering our questions. We'll let you know the results in the next few weeks.
Thanks, everybody. Have a great
Thank
day.
you.
Ciao.
Bye. Okay, let's start it. So the target is Phoenix Boring, and we're going to have Roberto presenting. Hi, Roberto.
Hi.
Hi, welcome to the online pitch. We are here in the room with EDP, and we're ready to hear your pitch. So you can go ahead, share your screen, and you have 4 minutes to pitch.
Sounds good. Thank you. So can you confirm that you're seeing my screen?
I can see it, yeah.
Okay, perfect. So, hi, we are Phoenix Boring, a vertically integrated utility tunneling service provider, which means that we develop, we build, and we deploy our own trenchless technologies in our own trenchless projects. And I mean, real projects as we speak. You guys are very familiar with this. The grid is expanding, but at the same time, we need to work on the resiliency, especially with the climate change. Unfortunately, this image is every time more common and to be seen. And there are two ways to underground utilities. You can do either traditional excavation, which is very disruptive, but there is a second option, which is utility tunneling, and it's installing a pipe without doing that disruption. But the problem is that this utility tunneling is still very costly today. And here you will see why. Here is an example. Unfortunately, a few months ago, we got these LA areas wildfires. And you can see in this example how the red line, the red areas here are where the fires were located, and the yellow lines is where the transmission lines were located. And if you see to the right side, the map, the geological map, you will see how different are the ground conditions here. And the more colorful this map is, means that you have more different ground conditions, very different ground conditions, and that makes very difficult for utility tunneling technologies to work in this type of situations. So after I graduate with a mechanical engineering degree, and I did a master degree in Europe, in management engineering. I have spent the last 13 years in the undergrounding industry. I'm also part of the board of directors of an international trenchless society, as well as being a frequent lecturer at many international industry conferences. And I have been also a professor of trenchless construction techniques. I started my first tech undergrounding company, and before I started with that company, I worked with some of the most well-known trenchless manufacturing companies, and the experience and knowledge I gained helped me to develop my own solutions, patented solutions. When I started my first company, Silver Trenchless, back in 2018, my goal was to develop a trenchless platform that could handle every ground condition and provide a tunnel at any size. And because of that, my inventions and patents were already have already won industry awards and being formally recognized as new methods. In 2022, I had a successful exit when my company was acquired by the Silicon Valley company called EarthGrid, also known as Petra, and I became the CTO of that company. Finally, last year, I decided to take over, and I bought back the IP and the machines from Petra, and I decided to start Phoenix Boring to keep pursuing my goal of making trenchless the go-to option in all undergrounding projects. So here are the three solutions that we have developed. The first solution is assisted dynamic boring. This is a technology specifically for unstable ground. We have developed also a technology for hard rock called jet boring. This is specifically for hard rock, as you can see in the video here. And what we call our ultimate solution is a swappable trenchless multi-tool platform able to change the boring method during the installation. And this is important because with that platform, we can do assisted dynamic boring, but we can do also with the same machine jet boring and many other technologies. So conventional technologies. And why this is important? Because when you are in the when you bid in a project, you need to establish a price before actually knowing the ground conditions. So if the ground conditions are different than you were expected, that translated to very big delays, which at the end transform into cost. So we have proof with real projects, and this, for example, a real example extracted from public bids in California, how cheap we can be compared with them. And we have already $2.5 million in bookings for the next few months to execute. So I personally have completed 69 pipe installations before starting Phoenix Boring. We have already 2.5 million in contracts and bookings. We are in average at least 2x cheaper in a simple geology, and up to 10 times cheaper when you know beforehand it's going to be a challenging ground condition. We are fundraising $4 million to deliver cash flow positive, and we have a $2 million contract with the Department of Energy for rapid undergrounding technology for electrical transmission and distribution. We are perfectly positioned to solve the dangers of electrical infrastructure by underground it. With that, I'm open to questions.
Okay, thank you, Roberto, for the presentation. Yeah, that's so professional.
Okay, thank you. So a couple of questions from my side. What is the smallest and the biggest hole you can make? Would be the first one. Then what's the speed? How many kilometers per day, or how many meters per day, or any metric you have with your technology? And the last one is, can you do directional drilling with your technology? Thank you.
Sure. So the first question was, again, can you repeat if you don't mind?
Yeah, sorry, I did too many questions.
Too many questions. Yeah.
Yes. What's the smallest and the largest
got it.
diameter you can? Yep.
And then the speed. Okay. So the smallest is 4 inches, and the biggest we have done tunnels 140 inches, 144 inches wide. Like
okay,
very very small to very big. Okay. Respect of speed, that depends on which technology are we talking about, because we have a platform with different technologies with the same platform. So if we're drilling through rock, and depending on the diameter, we can go as fast as 5 inches per minute. And if we're talking about regular ground, we can install in a day, in a single shift, 300 meters or so. So it depends of many factors, and the ground condition and the technology we're using in our platform. The most important factor is that we don't need to switch a different machine if we find a different ground condition, which allows you to. It's not that important how fast you go. It's important that the most importantly is that you don't need to change to a different machine, because otherwise that takes weeks or months when you for solving that type of problem. So, and the last question was
about directional drilling.
Oh yeah, we do straight lines. We install straight lines, but with the ARPA project, the one that we have with the Department of Energy, we are developing a special head that is going to be an add-on for horizontal directional drilling, and that will be steerable, that one. But we normally focus on straight lines, perfectly straight lines, because we guide by optical guidance system, so it's a perfect line. Because that opens for us the market not only for electricity but for water and sewer lines.
Okay, great. Thank you.
Thank you.
Your last question? One. So, Bert, thank you so much for your presentation and for answering our questions. And we'll let you know the results in the next few weeks.
Sounds good. Thanks for having me.
Thank you. Bye. Okay, that was it. So thanks everyone for the efforts. Thank you for being here and for all your questions. And tomorrow we have another full day of, I think, 21 startups as well. So yeah, have a good rest. And Vasco, I don't know if you want to say a few words.
Não, acho que aqui já podemos mudar para português, mas não está
Já,
por muitas horas de inglês, mas sim, obrigado a todos. Acho que aqui a maior parte das pessoas aqui
Sim.
tiveram quase o tempo todo, por isso obrigado e até amanhã.
Até amanhã. Obrigado.
Até amanhã.
Vale, obrigado, boa noite.
Obrigado, Pedro.
Boa noite.
Boa noite.
It's going down.